Hello, and welcome to the Ultimate Python course. In this course, you're going to learn everything you need to know about Python, from the basics to more advanced concepts. I will walk you through every line of code I write, step by step. By the time we finish this course, you'll feel confident writing Python code on your own. To take this course, you don't need any prior knowledge of Python or programming in general. Now, let me give you a short overview of all the topics I'll cover in this course. First, we'll set up the tools you need to write and run Python code on your computer. It doesn't matter if you're using Windows, Mac, or Linux. We'll get everything ready to go. Next, we'll learn about basic concepts of Python. What is a variable, identifiers, basic data types, typecasting, the input function, and so on. These are the building blocks of Python programming. After that, we'll move on to the section about conditional statements. Here, we'll learn about if statements, for loops, while loops, logical operators, and much more. Next, we'll dive into data structures. We're going to cover lists, sets, tuples, and dictionaries. After that, we'll move on to functions in Python. We'll cover what functions are, why we use them, how arguments work, and the concept of variable scope. Next, we'll dive into exception handling in Python. You'll learn what exceptions are and how to manage errors in your code using try, except, and finally. It's a key skill for writing robust programs. Afterward, we'll dive into object-oriented programming. We'll explore concepts like objects, classes, methods, inheritance, encapsulation, polymorphism, abstract classes, magic methods, and much more. Then, we'll move on to modules, packages, and virtual environments in Python. You'll learn how to organize your code by creating your own modules and explore how to use Python's built-in modules to make your programs more powerful and efficient. After that, we'll learn higher order functions, decorators, iterators, and generators. Finally, you'll learn how to interact with APIs using Python. We'll make a request to fetch weather data from a weather API called WeatherStack. By the end of this course, you'll have a solid foundation in Python and be ready to tackle more advanced topics. Let's get started. In this lesson, we'll set up the development environment. I'm using Windows, but you can use any operating system. Everything we're doing in this course is cross-platform, and all the tools we use work on any operating system. First, you'll need to install the latest version of Python. Let's go to python.org/downloads to download Python. Here, you'll see a yellow button labeled Download Python. Right now, the latest version of Python is 3.13.2. If you're watching this video later, there might be a newer version available, but don't worry. This course will still work for you. So, go ahead and click this button. Now, let's run the installer. If you're on Windows, make sure to tick Add Python exe to path. Once that's done, just click Install Now. To check if Python installed properly, open the command prompt and simply type Python and press Enter. If you're using a Mac, note that it typically comes with an older version of Python pre-installed. To use the newer version of Python, you'll need to type Python 3 instead of Python. As you can see, Python has been successfully installed. To write and run Python code, you'll need an IDE, which stands for Integrated Development Environment, or a code editor. For this course, I'll be using PyCharm as my IDE. It's a powerful tool that makes coding in Python much easier and more organized. You're free to use any code editor you prefer, but for a smoother experience, I recommend downloading PyCharm and coding along with me. This will help ensure we're on the same page and make it easier to follow along. To download PyCharm, let's go to the jetbrains.com/PyCharm. There are two versions available, Professional and Community. Since the Community version is free, we can use it for this course without any issues. Here, just follow the standard installation steps and you'll have PyCharm ready to go. The first time you open PyCharm, you'll see the welcome page. From here, click on New Project to get started. Here, we can specify the location of this project. I'm going to call this project Python Basic. Then, click the Create button to get started. Inside the project, we need to create a Python file. So, right-click, New Python file. Let's call it main. So, you can see we now have empty Python script. Here, I'll print a simple message. So, to print a message, we'll use the print function, which is a built-in function in Python. Let's say print. Inside the parentheses, type your message. Let's say, hello world. Whenever we want to work with text, we need to put the text in between quotes, either double quotes or single quotes. As you can see, the font size is quite small. Let's adjust it to make the text more readable. Let's go to the top menu and then select Settings. From there, choose Editor and then Font. I'll set the font size to 24. Also, I'll change the font family. This is a free font that you can easily download online if you'd like to use it. To run this Python script, we can simply click the green play button in the corner, or you can go to the Run menu at the top and select Run from there. Easy, right? When you run the script, it opens the terminal window at the bottom. This is the place where any results or messages from your program will be displayed. In this case, it displays the message, Hello World. The line at the end indicates that the program executed successfully, meaning there were no errors. If you want to print another line, simply add another print statement. Let's say, I love Python. This will display both messages in the terminal, one after the other. Congratulations, you've just written your first Python program. Imagine Python variables as containers or labels that hold information for you, like boxes where you store different things. When you create a variable, you're basically giving a name to a specific value or piece of data, so you can refer to it easily later on. For example, if you want to store someone's age, you could write age equals 25. Here, age is the name of the variable, and 25 is the value stored in it. In Python, there is no command for declaring a variable, so a variable is created the moment you first assign a value to it. Now, whenever you use the word age in your code, Python will know you're talking about that value, 25. One cool thing about Python variables is that you don't need to tell Python what type of data you're storing. If you store a number, text, or even a more complex structure, Python automatically figures out the type for you. This flexibility is great, but it also means you need to keep track of what's inside each variable because Python won't remind you later. You can always change what's stored in a variable. If you decide to update the age variable to 31, you just assign a new value to it. If I run the program again, as you can see, the age is now 31. In Python, you can assign a single value to multiple variables all at once using the assignment operator. This is really handy and saves time. For example, I'm going to create 3 variables, let's say x, y, and z. To all have the value 5, you can do it in one line like this. Now, if we print x, y, and z, you'll see that they all have the same value. This means x, y, and z will all hold the value 5 without having to repeat the assignment over and over. Now, let's see, what is actually happening when you make a variable assignment? This is a key question in Python, and the answer is a bit different from what you typically find in many other programming languages. In Python, when you create a variable and assign it a value, you're not actually storing the value directly in the variable. Instead, what happens is that Python creates the object for that value in memory, and the variable simply acts as a reference to that object. Think of it like a label or a tag that points to where the object is stored in memory. In this case, Python creates the integer object 10 in memory. The variable x points to that object. Now, let's say y equals x. What happens when it is executed? When we say y equals x, we're not creating a new copy of 10. Instead, we're making y refer to the same object that x is pointing to. Now, here's something important. Integers are immutable, meaning you can't change the value of an integer object. So, if you later change x to a different value, like this. Now, x points to a new integer object 20, but y is still pointing to the original integer object 10. So, the value of y will remain 10. Now, if we print these values, you'll be able to see that. Even though y was originally set equal to x, when we change x, it doesn't affect y because x is now pointing to a different object. There are a few rules for naming variables. We'll cover them in the next lesson. Now, let's discuss identifiers in Python. In Python, an identifier is simply a name we assign to things like variables, functions, classes, and more. It's how we label and refer to these elements in our code. When naming an identifier, you have to follow certain rules. If you don't, you'll get an error. So, let's take a look at the rules for naming identifiers. The first rule is that a variable name can contain only letters, numbers, and underscores. However, you cannot start a variable name with a number. It must start with a letter, either in lowercase or uppercase, or you can also use the underscore. The rest of the characters can be letters, underscores, or digits, but we can't use special characters like @ hash, $%, and so on. Also, Python is case sensitive, so these are 2 different identifiers. So, this one has a lowercase a and this one has the uppercase a, so that's why both of these variables are totally different in Python. There are also reserved keywords in Python that are used for specific purposes, and these cannot be used as identifiers. Also, identifiers cannot contain spaces. Now, let's look at conventions for naming identifiers. So, these are just conventions, not hard rules you don't have to follow. Number 1 is use descriptive and meaningful names for identifiers to improve code readability and clarity. Student name clearly explains that this variable holds the name of a student. We can use s_n for student name. If we run this, we will not get any error, but this name is not that descriptive. When someone else reads this code, they have no idea what SN stands for. So, always avoid using names that are too short or too cryptic. For multi-word identifier names, use underscores to separate words. So, these are all the best practices about naming identifiers in Python. Thanks for watching. See you in the next lesson. In this lesson, we're going to talk about comments in Python. A comment is a text that is added in a program to improve the readability of the program. This helps other developers easily understand the logic and purpose behind the code we've written. In Python, starting a line with a hash mark indicates that it's a comment. Everything after a hash mark is ignored by the Python interpreter. When we run the program, this line is going to be completely ignored. We can also place comments after the code like this. These are called inline comments. Python doesn't have built-in multi-line comments like some other programming languages. However, we can achieve the same effect by using a hash symbol at the beginning of each line. You can also use triple quotes for multi-line comments. However, we usually don't use triple quotes for comments, since they're mostly meant for documentation. A comment doesn't have to be just an explanation of the code. It can also be used to prevent Python from executing certain lines of code. Here, the first line is commented out, so Python skips it and only runs the second line. This is useful for temporarily preventing certain lines of code from running without deleting them. Finally, I want to leave you with this thought. When I wrote this code, only God and I knew what it did. Now, only God knows. This is exactly why writing clear comments is so important. By explaining your code clearly, you'll ensure that everyone, including your future self, can understand it later. Let's discuss numbers in Python. In Python, we have three types of numbers: integers, floating point numbers, and complex numbers. So, integer numbers are whole numbers without decimals, like 10, -4, or 0. Floating point numbers, also called floats, are numbers containing one or more decimals, like 2.5 or -6.45. Even 0.0 and 4.0 are considered floating point numbers. Even though technically there are whole numbers, because they don't have a fractional value, if Python sees this decimal here, it considers it a float. And the last data type within the numeric data type is called complex. Complex numbers are written with a J as the imaginary part. Now, if you use something like C or any letter other than J, you'll get an error. So, J is the only one that will work with it. We can verify the type of any object in Python using the type function. First, I'm going to create three variables. Let's say x equals 10, y equals 2.5, and z equals 2 plus 5j. Now let's check the data type of these variables using the type function. If I run this program, you'll see that the type of x is int, y is float, and z is complex. When a number is large, it'll become difficult to read. To make the long numbers more readable, you can group digits using underscores like this. In Python, underscores within numbers are purely for readability. So they help you format large numbers without affecting their value. Python completely ignores the underscores during execution. This feature has been available since Python 3.6, and you can use underscores in both integers and floats. However, you can't use underscores at the beginning or end of the number or directly next to a decimal point. For all these types of numbers, we have the standard arithmetic operations that we have in math. So here are the different arithmetic operators. We have addition, subtraction, multiplication, and division. Here you can see we have two different types of divisions. Single slash division gives us a floating point number, and double slash division gives us an integer number. It's rounding down to the nearest integer. If we run the program, we can verify this. We also have modulus, which is the remainder of a division. And finally, we have exponent, which is left to the power of right. These are the standard arithmetic operators. We can also combine these arithmetic operators with the assignment operator. Let me show you what I mean. Let's create a variable called x and set it to 5. Let's say we want to increment x by 2. We can write an expression like this: x equals x plus 2. We can also write this expression like this: x plus equal 2. This is known as an augmented assignment operator. These two statements are exactly the same. In this example, I'm using addition, but you can use any of these arithmetic operators here. Now, let's talk about strings in Python. A string is simply a sequence of characters. It can be enclosed in single or double quotes. If you're wondering whether there's a difference between single quotes and double quotes, they are actually the same in Python. However, if you use a single quote to start a string, you must use the same single quote to end it. The same rule applies to double quotes as well. Quite often, we use double quotes. We also have triple quotes, and we use them to format a long string. This technique allows us to include line breaks and preserve the formatting of the text across multiple lines without the need for explicit escape characters. It's particularly useful when working with large blocks of text or when you want to maintain the visual structure of the string in your code. Now, we have one more important point to consider. If single quotes are used inside the string, then the string should be enclosed within double quotes or vice versa. Here, the string contains a single quote within the word its, so the string is enclosed in double quotes. Here, the string contains double quotes around the word hello everyone, so the string is enclosed in single quotes. Now, let's look at escape sequences. Let's say we want to create a string like this. This string contains both single quotes and double quotes, but you can see there is a problem here. Let's run this program. And as you can see, we get an error. This is because Python thinks this part inside quotation marks is the string, and whatever is outside of that or following that is regular Python code. So, how do we solve this problem? We can escape characters like quotations by using a backslash before it. Now, let's run the program. As you can see, we're now getting the correct output. So, backslash is an escape character, and backslash double or single quote is an escape sequence. In Python, there are other escape sequences you should know about. Here, we have some of the common ones. Now, let's talk about the string length. Let's see how we can find the number of characters in a string. Let's suppose we have a variable called greeting set to welcome to Python. To get the length of a string, we can use the built-in len function. Let's say len, and then parentheses. Inside these parentheses, we pass our greeting variable. And this will return the number of characters in this string. So, let's print that and see what we get. let's run the program. We get 18 because we have 18 characters here. Now, let's talk about the string concatenation. We can concatenate strings in Python by using the plus operator. So, let's see an example. Let's say we have two variables, first name and last name. First name equal to James and last name equal to Smith. Let's suppose we want to print the full name on the console. For that, we can create another variable called full name. And let's combine first name plus. Then add an empty string. And then plus last name. Now let's print full name. Let's run the program. And here, you can see we get James Smith, which is the result of combining two different strings. Now we can achieve the same result using f strings. With this method, we don't need to use plus signs for concatenation. When concatenating more than two strings, using multiple plus signs can make the code look messy, and it's easy to forget to add them. By using formatted strings, the code becomes cleaner and easier to read. So, here we can say the full name equals a set of quotes. Now, before the quotes, we need to add the letter F, which can be lowercase or uppercase. Inside the quotes, we need to add two sets of curly braces. These curly braces are acting as a placeholder for a value or variable. We will place our two variables, first name and last name, within these curly braces. Also, we can add a space between the two variables. Now, let's run this program. We get the exact same result. So, when using formatted strings, we can put any valid expression in between curly braces. In this lesson, we'll see a few useful string methods. Here we have a string variable named book title and set to The Great Gatsby. Now let me go ahead and simply say print, followed by book title and a dot. And right here, you can see that we have a bunch of methods. These are all the available methods for strings. Now, let's take a look at a few of these methods. Let's say book title dot upper. This will convert the entire string to uppercase. Let's run the program. Here's what we get. Note that the methods you call here return a new string, so the original string remains unchanged. Let me show you. So, let's print the book title variable. Now let's run the program one more time. As you can see, our original variable didn't change. Okay, let's remove this print statement. We also have the lower method to convert a string to lowercase. We also have title, which will capitalize the first letter of every word. First, I'll change our string like this. Now, let's call the title method. We can see that the first letter of each word is now uppercase. We also have the capitalize method. This will capitalize the first letter of the sentence. Next, we have the isDigit method. This will return true or false depending on whether the string is a digit, which, in this case, it is not. So, this will print false. If I change this variable to a bunch of numbers like 1, 2, 3, 4, and then this will return true. Let's change that back. Next, we have the count method. It returns the number of times a given character occurs in a string. Let's say I would like to count how many G's are in here, and this should return 2 because there are 2 G's in our book title variable. If you want to get the index of a character or sequence of characters in your string, you can use the find method. Now, let's find the index of Gatsby. So, the index of Gatsby is 10, and that's because Gatsby starts at the 10th index of our book title variable. Python is a case-sensitive language, so if I pass a simple G here, let's see what we get. We get -1. That means this string was not found in the original string. We know that the find method returns the index of the first occurrence of a given character. Here we also can pass a character. Let's pass G here. The first occurrence of character G is at position 4. If you need the last occurrence, we have another method called rfind. Let's find the last occurrence of G. So we get 10. So now let's say that we want to replace some characters in our string with some other characters. And we can do this with the replace method. This method takes 2 arguments. First, it takes the character we want to replace, and the second argument is the character we want to replace it with. Let's say I would like to replace all uppercase G's to lowercase g's. If I run the code, you'll see that all uppercase G's are now replaced with lowercase g's. So, we saw a lot of different methods that we could use on our strings. Now, if we ever wanted to see everything that's available to us, then there are a couple of things that we can do. So, first we can use this dir function. What this does is if we pass in a variable, then it will show us all of the attributes and methods that we have access to with that variable. So, this doesn't show what any of these actually do. To see more information about these string methods, then we can use the help function. Here, let's type help str for string. As you can see, this provides much more information, including a description of what these methods do and the arguments they take. Now, if you know that you had a certain method available to you, but you couldn't remember exactly what it does, then you can actually pass it directly into help also. So, let's say we want to find out some more information about the find method. We could say str.find. Now, if we run this, we can see that it gives us information and the description just of what the find method does. In the previous lesson, you learned how to format a string using fstring. In Python, there's also a method called format that we can use to format a string. Let's say we have 3 variables called name, age, and weight. Now, let's say we want to print this sentence. Brandon is 40 years old and weighs 180 pounds. So, let's write this using the format method. Let's say print. And inside the quotes, we need to add a curly braces for name, and then is, and again a curly braces for age, and then years old and weighs. And then add another curly braces for weight, and then pounds. Now we need to use the format method. So here let's say dot format. Now, inside the parentheses, we need to pass our variables. Let's pass name, age, and weight. So, now, these curly braces will be replaced by the contents of these variables. Now, if we run the program, we get this output. Now you need to remember this. If you pass these arguments in a different order, you'll get the wrong output. So, you need to pass the arguments in the correct order to ensure the expected result. In the next lesson, we'll look at how to access characters in a string. In this lesson, we're going to learn how to access individual characters in a string. Let's say we have a variable called username and set it to James. So, in this username string, we have a total of 5 characters. Each character receives a number starting from 0 up to the length of the string -1. So, in this case, it will be 0 to 4 because there are a total 5 characters in this string. Each character will receive a unique number, and these numbers are called indices in Python. We can access each character of a string with the help of these indices. If you want to get access to a specific character in this string, we use the square bracket notation. Let's say we want to access the first character in this string. So, I'll say username, and then square brackets. Inside the square brackets, let's put 0. With this, we can access the first character of the string. So, now if we print this, we'll get letter J. In this way, we can access the individual characters of this string. Now, if you accidentally try to access an index that doesn't exist, then you'll get an index error. So, if we were to attempt to access an index that is out of bounds, such as index 5 in our example, Python would raise an index error. This error occurs because we're trying to access a character position that doesn't exist within the string. Remember, our username string James only has indices from 0 to 4, so index 5 is beyond its length. Now we can also use a negative index like -1. So that returns the first character from the end of the string. So indexing starts at the last index -1 and goes up to the length of the string. If we have any string, or let's say if the user has provided a string, and if we want to access the last character of the string, then we can easily access the last character by just writing -1, and we do not have to know the length of the string. This is the benefit a negative index provides us. Now let's look at how to access the substring of a string. A substring is simply a part of a string. Now, let's say we want to extract the first 3 characters in this string. So, here we need to indexes. The start index, colon, and the end index. So, this will return a new string that contains the first 3 characters in this username variable. Let's run the program. So, we'll get J, A, and M. The index of these characters are 0, 1, and 2. That means the character at the end index is not included. So, you need to remember that the start index is inclusive, which means it's going to include that value, but the end index is not. Now, what if we don't include the end index? What do you think we're going to get? So, this will return a new string that is exactly the same as the original string. We can remove the start index. In this case, it will assume that we want to start at the beginning. We can also omit both indexes as well. This will also return a new string that is exactly the same as the original string. We also have an optional field called step. So, step is how much we're increasing our index by between starting and stopping. Here, we need to add another colon and then specify the step value after it. The default step value is 1. Let's change it to 2. As you can see, now we're getting every second character. We can also give negative indices. So we will get AME as a result. So this is all about accessing substrings of a string. Also, we can reverse a string in Python by using the step value. To reverse a string, we need to use a step value of -1. And that's how you can reverse a string in Python using slicing. Now let's talk about something called the Boolean. So, a Boolean is a data type that allows us to tell our program whether something is true or false. Let me show you an example. Let's say we have two variables, is logged in and has access. Now, is logged in is true, and has access is false. Please note that in Python, the first letter of true and false is always capitalized. Also, make sure that you don't wrap true and false around with quotes, otherwise they would be treated as strings. Now, let's print these two variables in the console. We can also check these variable data types using the type function. And we'll get bool, which is short for Boolean. When a value evaluates to true, it's truthy, and if a value evaluates to false, it's falsy. To find out if a value is true or false, you use the bool function. For example, let's check the number 1 using this function. You can see we get true. If you check 0, now we get false. In Python, when using the bool function on numbers, only 0 returns false. All other numbers, whether positive or negative, will return true. An empty string also returns false, but a non-empty string returns true. Similarly, an empty list gives false, while a non-empty list gives true. In Python, these values are evaluated as false. The truthy values are the other values that aren't falsy. In this lesson, I'm going to teach you typecasting in Python. Typecasting is the ability to convert the data type of a value to another data type. Typecasting is sometimes referred to as type conversion. There's two main ways that typecasting occurs in Python. There is implicit typecasting and explicit typecasting. Implicit typecasting is typecasting that occurs automatically as part of the execution of a Python program. Explicit typecasting is when we as the programmer explicitly decide to convert a value of 1 to a value of a different type. First, let's go over an example of implicit typecasting. Let's create a variable called x and assign it the value 5, where 5 is an integer. Next, let's create a variable called y and assign it the value 5.5, where 5.5 is a float. Now, I'm going to reassign the value of x. Let's set x to x plus y. Now, I'm going to print the value of x. If we run this program, you'll see the result is 10.5. So, now x is a float data type because it has a decimal portion. We can verify this using the type function. As you can see, the type of x is now a float. This is called implicit typecasting. Now, let's take a look at explicit typecasting. Let's say we have 4 variables, each representing one of the 4 basic data types in Python. Let's do some explicit conversion. Let's convert variable quantity into a floating point number. Let's say quantity equals, then type float a set of parentheses, and then add quantity variable, and then print the quantity variable. As you can see, the value of quantity is now 10.0. Now, the data type of quantity is float. We can verify this by using the type function. That's how you convert a value to a floating point number. Now I'm going to convert the price variable into an integer. Let's say price. Set this equal to type int, set of parentheses, and then place price variable within the parentheses. Then I will print the price variable. As you can see, the price is now 19. Let's also check its data type. That's how you can cast a value to an integer. Let's turn a value into a string. For example, let's convert this Boolean value into a string. To convert a string, we can use the str function. And then print our variable. It might look the same as before, but we can check the data type. So, to convert a value or variable into a string, you can use the built-in string function. We can convert a value or variable into a Boolean. Boolean can only be true or false. Let's convert the color variable to a Boolean. Let's say color equals to bool. And inside the parentheses, let's pass our color variable. And then let's print the color variable. As you can see, we get true. We can verify this using the type function. The input function is used to take input from the user. No matter what kind of input it is, we can take input from the user and store it in some variable. Let's create a variable called age and set it to the value from the input function. We can pass a string as an argument inside the input function. Inside the quotes, let's type enter your age. This will show up as a label in the terminal. It's not required, but it helps the user know exactly what kind of input to provide. Now, we can say print your ages, and then we just can concatenate that with the variable age. Now, let's run the program. Now our program will wait for us to enter some input. I'll type 30 for the age. As soon as we press enter, we get this message, your age is 30. So, this is how we are going to be getting input from the user. Now, when we receive input from the user, this input always comes as a string. So, there are a few problems with this. Let's say later on, we decide to perform some operations with the age. For example, let's say we want to print the user's age next year. So, we need to add 1 to the user's age. We can write age equals, age plus 1. Now, let's change this print message. Let's say next year your age will be. Then plus and age. Let's run the program one more time. And now we get this error. It says type error can only concatenate str, not int. So what's happening here is that the input function actually returns a string. So here we're going to add an integer value to a string value. That's why we get this error. This means we need to typecast this value to an integer. We can pass the input function as an argument to the int function to handle typecasting. Let's run the program. Now we get another type error. It says can only concatenate string to string. So you cannot normally display a variable of the integer data type along with strings because we're doing string concatenation. We would need to convert this variable back to the string data type. We can use the str function to convert age to a string. Let's run this program one more time. Now, we get the correct result. Here we could also use a f string like this. This time we don't need to typecast the age variable to a string data type. In this lesson, I'm going to explain format specifiers in Python. Format specifiers in Python are used to control the formatting of strings, particularly when inserting values into strings. They allow you to specify how the value should be displayed, including aspects like width, precision, and alignment. So, when we use the newer formatting methods like the format method or fstrings, we can specify additional formatting options within the braces. Let's see an example. I'm going to create a variable called pi and equal to it this value. Now, let's display this pi value using fstrings. Now, within our placeholder after the value, we can add a colon. After the colon, we can add the format specifiers. They will format our value in a specific way depending on what we insert after the colon. Let's say we want to display only 2 decimal points. So, after the colon, let's add a dot and 2. Then f. Here, f means floating point number. Now, let's run the program. As you can see, it only has 2 decimal points. So, you can even add a 4 if you want. You can also add 0 if you want. So, you can add whatever you want. Let's say we have a variable called number, and it's equal to a big value like this. Now, something like this gets quite annoying because you have to count how many zeros there are, and you don't really know if it's 1,000,000 or 100,000. So, we have a 1,000 separator, which is a comma. Now, after the colon, we can add a comma like this. If we run the program, you can see that each thousands place is now separated with a comma. We could also mix and match format specifiers. As you can see, now we also have 2 decimal places with this number. Let's say we want to print this number in scientific notation. For that, we can add 0.0, e like this. Now, we get the scientific notation of this number. Now, the next thing we're going to do is talk about alignments. First, create a new variable called city and set it to New York. Now, let's create a f string. Next, we can add a colon. And after the colon, we can say whether we want to align it to the left, to the right, or whatever we want. The left angle bracket is used to left align the text. The number 10 specifies that the output should occupy a total of 10 characters of space. If we run the program now, you probably won't notice the change. However, if you add some text after the city variable, it becomes clearer. As you see, it is going to occupy 10 characters of space inside here for this variable. Now, if you put something that is less than the variable length, it's just going to use the normal space. To align text to the right, we can use the right angle bracket. As you see, now the city name takes up 10 characters of space and shifts to the right. We also have center alignment. For that, we use the caret symbol. You can also fill the extra spaces with a specific character by placing it before the alignment specifier. You can choose any symbol to fill the empty space. So, that's it for this lesson. I'll see you in the next lesson. In this lesson, we're going to learn about the comparison operators in Python. We use comparison operators to compare two values. These operators return a Boolean value based on the comparison result. They are also called relational operators. Now, let's see the list of comparison operators in Python. The first operator is greater than. Next, we have less than operator. The third operator is equal to, which is denoted by double equal signs. Next, we have less than or equal to. We have greater than or equal to. The last comparison operator is not equal to, which is denoted by the exclamation mark and equal sign. So, these are all the comparison operators available in Python. So, the first thing that I want to do is declare a variable with the name x, and I'm going to be storing the value of 6 inside there. We have another variable called y, and it's set to 3. Now, let's compare these two variables using these operators. So, here we have x is greater than y. If we run this, we get true because 6 is greater than 3. Here we have x is greater than or equal to y. Once again, we get true. We also have less than. This gives us false because 6 is greater than 3. Here we have x is less than or equal to y. Still, we get false. Next, we have the equal to operator. This will give us true if two values are equal. Once again, we get false because x and y are not equal. Now, let's change the y value to 6.0. This time we get true. Here, x is an integer and y is a floating point number. But we still get true when comparing them. That's because Python automatically converts the integer to a float before performing the comparison. However, the comparison of an integer 6 and a string 6 gives us false. Finally, we have the not equal operator. Now, this expression evaluates to true because an integer 6 and a string 6 are not equal. In this lesson, I'm going to explain if statements. In nearly every program, there are moments when decisions need to be made. This is where if statements come in handy. So, if statement allows us to decide whether a particular statement or block of statements will be executed or not based on some condition. Let's look at the syntax of the if statement. First, we have the if keyword, followed by the condition we want to check. After the condition, we have a colon, which is mandatory. This condition is an expression that evaluates Boolean value. If this expression evaluates to true, the following statements will be executed. As you can see, these statements are indented. This clearly indicates that this block of statements will be executed if the condition is true. So we can have as many statements as we want here. As long as they are indented, they belong to this if block. Now, when we finish here, we should remove indentation to indicate the end of this if block. The statement outside if block will be executed regardless of whether the condition in the if statement is satisfied or not. So, it does not depend on the condition of the if statement. In Python, we use whitespace and indentation to construct the code structure, and this brings several important benefits. First, it makes it easy to spot where a block of code starts and ends. You won't run into the confusion that can happen in languages like Java or C++, where curly braces are used and might get misplaced or forgotten. Second, Python ensures a consistent coding style throughout. This means when you're reading or working on someone else's code, it will look familiar and be easier to understand because the structure is the same as what you're used to. Lastly, using indentation like this makes the code much clearer and easier to read compared to languages that rely on other ways of separating code blocks. Now, let's look at an example of an if statement. Let's write a program that asks the user for their age. We can do this using the input function. Let's create a variable called age and assign it the value from the input function. Inside the parentheses, let's type enter your age. Now, I'm going to typecast the input as an integer. Based on the user's age, we can determine if they are eligible to vote. Let's say if the user's age is 18 or older, they're eligible to vote. Therefore, we can write an if statement like this. If the user's age is greater than or equal to 18, and then colon. So, if this condition is true, let's print, you are eligible to vote. As you can see, our code is indented. After the if block, let's add another statement. Let's print this message. Now, let's run the program. Here, let's type 30 for the age. Since the age is greater than 18, the condition is true. So, we get the message, you are eligible to vote. We also see this other message because any code outside the if block runs whether the condition is met or not. Let's run the program one more time. This time, let's say age is 10. Now, we only get this message because the age is below 18. Now, let's look at the else statement. The else statement can be used with the if statement to execute a block of code when the if condition is not satisfied. After the if statement, let's add the keyword else. Make sure your indentation is correct. You don't want this part of the code to accidentally fall inside the if statement block. If someone's age is less than 18, let's print, you are not eligible to vote. Now, let's run the program. Let's say age is 16. As you can see, we get these two messages. So, the else statement will be executed when the if condition is not satisfied. Let's run the program one more time. This time, let's say age is 25. Now, we get these two messages. If we have multiple conditions to check, we can use the elif statements. So, elif that is short for else if. We can have as many elif statements as you want. So, after the if block, let's say elif age is less than 0. If this is true, let's print this message. Now, let's run the program. Let's say age is minus 10. This condition is false because the age is not greater than or equal to 18. So, we skip this statement. Now, this condition is true because the age is less than 0. Therefore, we will print this message. So, the if-else statement is used when you need to choose between two options. The if, elif, else statement is for when you need to choose between more than two options. In this lesson, we're going to learn conditional expressions. A conditional expression is a one-line shortcut for using an if-else statement. Now, let's write this if-else statement using a conditional expression. To write a conditional expression, here's the formula. Return x if our condition is true, else return y. So, let's return the string eligible if the age is 18 or older. Otherwise, let's say else. And then return not eligible. Now let's create a variable called message and set it equal to this expression. Then we'll print our message variable. Now, let's run this program. You can see we get the message eligible because age is greater than 18. Let's change the age to 15. Now we get this message not eligible. This is the conditional expression in Python. It provides a concise one-line shortcut for the if-else statement. Now let's talk about logical operators in Python. So, logical operators are used to perform logical operations on Boolean values. And these operators allow you to combine or modify Boolean values and make more complex decisions in your code. In Python, we have three logical operators: the AND operator, the OR operator, the NOT operator. The AND operator returns true if both the conditions are true. Otherwise, it returns false. Let's see an example. Let's say we have two variables, age and hasId. Age is 25 and hasId is true. Now here's the condition we want to implement. If the user's age is 18 or older and they have an ID, then they are eligible to enter the club. We can use the logical AND operator along with if statements to check both conditions. So, if age is greater than or equal to 18 and hasId equals true. Then let's print, you are eligible to enter the club. Here, I have not compared the value of this variable to true. Because hasId is a Boolean, it's either true or false. We don't need to compare true with true. If one of these conditions is false, we will not see an output in the terminal. So, Let's print another message if this condition is false. For that, we can add an else statement. Let's say else, and then we will print, "You cannot enter the club." Now let's run the program. As you see, we get this message. You are eligible to enter the club. Now let's change has ID to false. Let's run the program again. This time we get you cannot enter the club. So, with the AND logical operator, in order for this entire condition to be true, both conditions must be true. In this case, our first condition is true, age is greater than 18. But our second condition is false. That's why we get this message. So, this is how the AND operator works. Now let's discuss the OR operator. With the OR operator, as long as at least one of the conditions is true, the result will be true. This means that it will return false only when both the conditions are false. So, let's replace AND with OR. Let's run this. Now you can see we get this message, you are eligible to enter the club. Now let's change the age to 16. Now if we run this code, we'll get the message, you cannot enter the club. So, with the OR operator, as long as at least one of the condition is true, the result will be true. Now let's take a look at an example of the NOT operator. The NOT operator inverts the condition. It returns true if the conditional expression returns false, and it returns false if the conditional expression returns true. Let's create a variable called isRaining and set it to false. Now let's write the condition. Let's say if, then not is raining. So, if this condition is true, then print this message. You can go outside without an umbrella. Else, print this message. You should take an umbrella. Now let's run the program. The NOT operator basically inverses the value of a Boolean. So, in this case, isRaining is false. When we apply the NOT operator, the result will be false. So, in this case, our condition will be true, and that's why we get this message. Let's say isRaining is true. When we apply the NOT operator, it will get false. So, our condition will be false, and we'll see the else message. So, those are logical operators. They allow us to evaluate multiple conditions. In Python, short-circuit evaluation occurs when evaluating logical expressions with the and/or operators. Python stops evaluating the expression as soon as the result is determined, which can optimize performance and prevent unnecessary computations. In this example, the Python interpreter will first evaluate the first condition. If this is true, it continues the evaluation to see if the second condition is also true. So, it continues the evaluation all the way to the end of this expression. However, as soon as one of these conditions is false, the evaluation stops. Let's say a equals 3. When Python evaluates this expression, it stops as soon as the first condition is false. Since both conditions must be true for the entire expression to be true, there's no need to check the second condition if the first one is false. This is what we call short-circuiting. The same concept applies to the OR operator. With the OR operator, we know that at least one of the conditions should be true. So here Python stops evaluating as soon as it finds the first condition is true, since only one condition needs to be true for the entire expression to be true. Short-circuiting makes code more efficient and safe, especially when dealing with costly or risky operations. Let's talk about the loops in Python. Loops allow you to repeatedly execute a block of code as long as a specific condition is met, or to iterate over a sequence of elements. So, for example, if you want to display a message 10 times, you don't need to write the print statement 10 times. Instead, you can use a loop to do it automatically. Python supports two types of loops. The first one is a for loop, and the second one is a while loop. In this lesson, we'll be learning about for loops. A for loop will execute a block of code a fixed number of times. You can iterate over a range, a string, a sequence, anything that is considered iterable. Let's look at the for loop with range function. The syntax of the range function looks like this. The range function has 3 arguments. According to these 3 arguments, the range function will return a series of numbers. The first argument is start, which represents the starting position of the sequence. The default value is considered 0. The next argument is stop, which represents the stopping position of the sequence. Just remember, the stop value in the range function is never included in the output. For example, let's say that the start value is 0 and the stop value is 4. So, we will get the sequence 0, 1, 2, and 3. We will never get the 4 in the result. Also, note that stop is the mandatory argument. The third argument is the step argument, which specifies the increment value, and the default value is 1. Note that the start and step arguments are optional, while the stop argument is mandatory. Now, let's create a for loop, and suppose we need to count to 5. To start our for loop, we're going to say for, and then we're going to give it a temporary variable for this for loop. So, for this one, we're just going to say number. Then let's type the keyword in, and then we will use the range function. Inside the range function, let's put 5, and then add a colon. The next line or lines will be indented. Inside this block, I'll use the print function to display the value of the number variable. Now let's run the code. We ran this for loop 5 times. Notice that it begins at 0 and stops at 4, since the range function doesn't include the stop value. If we want to start with 1 to 5, we can pass 2 numbers in our range function. Let's pass 1 and 6. The first number will be the starting point, and the second number is the ending point. This first number is inclusive, and the second number is exclusive. That's why we use 6 here. Now, let's run the code one more time. As you can see, we have begun at 1, and we have counted all the way to 5. Now, let's look at an example with a step argument. In this example, the starting number is 1, and the ending number is 10. Here, I'm passing 2 as the step value. So, this program will now count up by 2. Now, let's run the code. So, we get the sequence 1, 3, 5, 7, and 9. Now, let's learn how to reverse a range of numbers using negative step value. Let's say that we want to print numbers from 10 to 1. So, here the starting number is 10, the ending number is 0, and the step value is -1. Let's run the program. As you can see, we get 10 to 1. In this way, we can reverse a range of numbers using a negative step value. In Python, strings are also iterable. So, here we can add a string. Let's add the word hello. Also, let's change this variable number to character. Now, in each iteration of the loop, the variable will hold one character from the string. In the next lesson, we'll learn while loops in Python. They're another powerful way to repeat code, but with a different approach. In this lesson, I'm going to explain while loops in Python. A while loop is a control flow statement that allows a block of code to be executed repeatedly as long as a specified condition is true. So, our for loops iterate through a certain number of values, but while loops will just keep going until a certain condition is met. Let's take a look at the while loop syntax. A while loop starts with the keyword while, followed by a condition and a colon. Then we write the body of the loop in the next lines. If the condition is true, the statements inside the loop are executed. The while loop ends when the condition is no longer true. Now let's look at an example. Let's create a variable called number and set it to 1. And then we'll say while number is less than 10. And then I'm going to print this number. After that, we need to add a counter. We're going to say number equals number plus 1. Also, we can write this statement using the augmented assignment operator. So, let's say number plus equal 1. I think this way is more cleaner and shorter, but you can use whatever you like. Now, let's run this program. So, you can see we get 1 to 9. Let's see what's going on here. First, the number is 1, and we're evaluating number less than 10, which comes out to true because 1 is less than 10. That means we come here and execute these statements. So, we're printing the number, right here, we're printing 1. And then we're adding 1 to the number. So now the number is 2. And we evaluate this again. So this time, 2 is less than 10. So here we're printing 2. And then again, we're adding 1. So then now the number is 3. And we evaluate this again and again until the number equals 10. So 10 less than 10. So that's false. This means we will get outside of this while loop. So this is the basics of how a while loop works. Now, if I comment out this increment statement and run the code again, the loop will keep running forever because the condition will never become false. So, this is called infinite loop. In this case, this statement is always true. If the condition never becomes false, we will get an infinite loop. So, the only way to break out of it is to actually stop running the program. Here, we can stop the program by pressing this stop button. You can see the loop is now terminated. So, always remember to add the counter. Thanks for watching. In this lesson, we're going to learn nested loops in Python. A nested loop in Python is a loop inside another loop. It doesn't matter if it's a for loop or a while loop. We can write a for loop inside another for loop or a while loop inside another while loop. Similarly, we can write a while loop inside a for loop or a for loop inside a while loop. The loop on the outside is the outer loop. The internal loop within the outer loop is known as the inner loop. In a nested loop, the inner loop runs completely for each iteration of the outer loop. Let's see an example. Let's print this pattern using nested for loops. First, let's create the outer for loop. Let's say for I in range 1 to 6. We use 6 for the end index here because our pattern has 5 rows. Now, inside the outer for loop, we need to create inner loop. Let's say for j in range. Inside the inner loop range function, we need pass this I variable. Here we use I for this inner for loop range function. Because for each value of I, we need to run the inner for loop I times. Now, inside the inner loop, let's print the star or the asterisk mark. Now, let's run the program to test it. Here we have an issue. After we use the print statement, we will enter a new line character and move down to the next line. We can actually prevent that by adding end equals quotes. Now, this will prevent our cursor from moving to the next line. Now, we need to print a new line once we exit the inner for loop. So, here, the outer loop controls how many lines are printed. The inner loop controls how many stars are printed on each line. Now, let's run this program. Here we have our triangular pattern. Now, let's look at two important keywords when working with loops: break and continue. First, let's look at the break statement. So let's say that we're looking for a certain number in our sequence. And once we find it, we don't need to continue looping through the rest of our values. Now, this is when the break statement comes in handy. I'll create a for loop to print numbers from 1 to 5. So let's say for number in range 1 to 6. And then I'll print the number. If I run this program, as you can see, we get 1 to 5. So now, let's say that we're looking for number 3. Here, I could say if number equals 3. And then within this if statement, I'll break out of that loop using the break keyword. Now let's run this program one more time. So, we can see that it looped through the numbers 1 and 2. Once it reaches the number 3, it exits the loop. So, the break statement breaks out of the loop even if the condition is true. But what if we wanted to just ignore a value but not break out of the loop completely? So, to this we can use the continue statement. Now, continue will skip to the next iteration of a loop. So, let's replace this break statement with continue. Now, let's run the code once again. So, as you can see, we have the numbers 1 through 5, but we have skipped the number 3. So, to skip over an iteration, you can use the continue keyword. The break keyword will completely break out of a loop, and the continue keyword moves on to the next iteration of the loop. We can also use the break and continue keywords inside a while loop. In Python, the pass statement is a null statement, which can be used as a placeholder for future code. Let's say you need to create a loop or a decision-making statement. However, we are not sure yet what its body will be. Let me show you an example to make it clearer. Let's say we have a for loop like this. Now, if I run this program, we get an indentation error. We're getting this error because the body of the if statement is empty. So, if you have a control structure like this, where you need to implement some condition, but do not want to take any action for now, you can use a pass statement. Now, if we run the program one more time, you'll see that it runs without any errors. So, the pass statement helps maintain the structure of your code while you are still working on its implementation. It allows you to write syntactically correct code without actually performing any operations. In Python, a loop can have an else statement, which is executed when the loop finishes normally. However, if the loop is exited prematurely using a break statement, the else block is not executed. This is the syntax of a for loop with an else statement. First, we have the for loop. Then we have the else statement. The else block will only be executed when the loop terminates normally. And this is the syntax of a while loop with an else statement. First, we have the while condition. If this condition is satisfied, then the statements inside the while loop will be executed. If this condition becomes false, then the else block will be executed. Let's see an example. Now, if I run this code, you can see that our while loop did run. So, it printed off 0 to 4. But then it also prints the else statement here. So, in this example, our while loop finished normally. Now, let's terminate this while loop by using the break keyword. Now, let's run the program. Here you can see that the while loop exited early using a break statement, so the else block was skipped. This is called the abnormal termination, as this is not the termination that happens because of the while condition. Now let's change this 3 to 6. Now let's run the code one more time. Now you can see it prints 0 to 4 and prints the else statement code block because in this case it didn't hit this break statement. So that's it for this lesson. I'll see you in the next lesson. In this section, we're going to be learning about a lot of data structures, including lists, sets, tuples, and dictionaries. First, let's look at lists. In Python, a list is a versatile and widely used data structure that allows you to store a collection of items in a single variable. It is one of the built-in data types and is commonly used to hold an ordered sequence of elements. Lists can contain elements of different data types, including numbers, strings, and even other lists. You can create a list by placing items inside square brackets separated by commas. For example, here we have a list of numbers. I've created a variable called numbers and assigned it a list. Without a variable, we wouldn't be able to refer back to this list later in the code. This list has 5 elements. As you can see, the elements are placed inside square brackets and separated by commas. We can also have a list of strings. We can even mix different types of elements in a list. In this example, we have an integer, a floating point number, a string, and another list. We can display a list using the print function. So, this will print all of the items found in this list. We can get the number of items in that list using the len function. So, here we can print the length of the fruits list. We get 3 as the length of the list because there are 3 items in it. Using the in operator, we can find if a value is within a list. Let's find out if banana is in our list. Inside the print function, let's say banana in fruits. This will return a Boolean value. If we run this program, you'll see the output is true because banana is in the list. Now, let's check if kiwi is in the list. This time we get false. We can use square brackets to access individual items in this list. So, let's print the first element of the fruits. Let's say print, and let's pass in the name of the list, which is fruits, and then 0. The reason we use 0 to access the first item in a list is that Python lists are 0 based. This means the counting starts at 0, not 1. So, when we run this program, we'll get apple. Now, similar to strings, if we pass a negative index here, like -1, this will return the first item from the end of the list. So, we get cherry. Using square brackets, we can also modify items in the list. So, let's change the first item to mango. And then print the entire list. As you can see, the first item in our fruit list is now updated to mango. Earlier in the course, we learned that we can use two indexes to slice a string. We have the exact same concept here. So, we add square brackets, 0:2. And this will return a new list with the first two items in our original list. So, if we print our original list, you can see that it's not changed. Just like strings, if you don't specify the first argument, 0 will be assumed by default. So, as we can see, we get the same result as before. Similarly, if you don't include the ending index, by default the length of the list will be used here. So, this expression will return a new list with all the items in the original list. Similarly, we can also exclude the start index here. With this syntax, we can get a copy of our original list. We can also pass the step argument. This is useful in situations where you want return every second or every third item in the original list. Now when we run this code, we'll get mango and cherry. Now let's learn how to loop over list. We can use a for loop to iterate over this list. Let's say for fruit in fruit colon, and then we print each item. This is how we iterate over a list. Let's learn how to perform various operations on a list using Python's built-in methods. These methods make it easy to add, remove, or modify items in a list. To access these methods, type the name of the list, followed by a dot, and you'll see a variety of options to choose from. First, let's look at how to add new items to a list. So, for adding items, we have two options, depending on where you want to add this new item. If you want to add an item at the end of the list, you should use the append method. Let's say we want to add mango to the list. To verify this, let's print the list using the print function. As you can see, mango is now at the end of the list. Now, if you want to add an item at a specific position, you should use the insert method. Let's say we want to add kiwi to the beginning of the list. Here we need to pass 0 for the index, and the second argument will be the fruit name. So, this is what we get. We can use the sort method to sort a list. Now, our list items in alphabetical order. To reverse a list, you would use the reverse method. However, these are not in reverse alphabetical order. These items are reversed based on the order in which we place them. If you like reverse alphabetical order, you can first sort and the reverse. Sometimes you may want to find the index of a specific item in a list. So let's say we want to find the index of kiwi. For that, we can use the index method. So this will return 0. Let's see what happens when an item isn't found in the list. Let's check index of peach. Now, we get an error because peach is not in the list. To prevent this error, you should first check if the item exists in the list using the in operator. So, if peach is in fruits, then we will print its index. Let's run the code, and as you can see, we don't get any errors. We can count the amount of times that a value is found within a list, because in list, we could have duplicates. So let's count how many mangoes in this list. There's one mango found in this list. Let's count how many peaches in this list. So we get 0. We can also remove an item from the list. If you want to remove the item at the end of the list, you should use the pop method. This will remove the mango at the end of our list. As you can see, mango is gone. You can also pass on index here to remove the item at the given index. So, if you pass 0, first item will be removed. Now, there are times that you want to remove an object, but you don't know its index. For that, we can use the remove method. Let's remove banana from the list. If you have multiple fruits with the same name, only the first occurrence will be removed. To remove all the fruits with the same name from the list, you'll need to loop through the list and remove each occurrence of the fruit with that name. If you want to remove all the objects on the list, you should use the clear method. So, we get an empty list. In this lesson, I'm going to be explaining 2D lists. A 2D list in Python is essentially a list of lists, where each sublist represents a row and the elements within those sublists represent the columns. This structure allows you to create a matrix-like layout, which is commonly used for representing grids, tables, or any kind of data that naturally fits into rows and columns. Here's a simple example of a 2D list representing a 3x3 matrix. You can access elements in a 2D list using two indices. The first index specifies the row and the second specifies the column. If I need the first number from the first row, that would be row 0, column 0. Let's print number 6 from the matrix. So, the first index to be number 1 and second index to be number 2. If we try to access 1, 3, that index is out of range, because we only have 3 elements within this row. To modify an element, just use its index to locate it and assign a new value. For example, let's update the number 5 to 10. So, The number 5 is at row 1 and column 1. Now we can set this to the number 10. Now let's print our matrix. As you can see, the number 5 has now been updated to the number 10. We can iterate over the rows with a single for loop like this. This will give us each individual list in our matrix. To get individual elements, we can use a second for loop. Using nested loops, we can iterate over all of the elements found within our 2D list. We can organize this more like a grid layout by passing an additional argument called end to the print function. If we set the end argument to a space, the elements of each row will be printed on the same line, with a space separating them instead of a new line. Now we need to use an empty print statement to separate each row. We can add this when exiting the inner loop. Let's run the code one more time. Now we get this grid structure. List unpacking in Python is a powerful feature that allows you to assign the elements of a list to multiple variables in a single statement. So we can unpack this list into multiple variables. Let's define 3 variables called first, second, and third, and then equal them to this fruits variable. Now if we print the first, second, and third variables, we will get the names of the individual fruits. So, this first variable will hold the name of the first fruit, which is apple. This second variable will hold the name of the second fruit, which is banana. And third variable will hold the name of the last fruit, which is cherry. This is what we call list unpacking. Now, what's important here is that the number of variables on the left side of the assignment operator must match the number of items in the list on the right side. So, if we exclude third here and run this program, we will get an error. Value error, too many values to unpack. So, there are too many items in this list and we cannot unpack it into enough variables. What if in this list we have so many items, but we only care about the first 2? We don't want to define so many variables on the left side of the assignment operator. So we can get the first and second and then pack the rest inside of a separate list called rest. With this syntax, we'll get the first and second items and everything else will be stored in a separate list called rest. So let's print variable rest. As you can see, rest is a list of all the items after the second item. So in this example, we have both unpacking and packing. You can also unpack elements using the asterisk operator to catch remaining elements, allowing you to ignore some elements. Let's say we want to get the first and the last item. So we can place rest between the first and the last variables. Now let's print these variables to see their values. Here, first gets the first element, last gets the last element, and rest captures everything in between. List comprehensions in Python provide a concise way to create lists. They are essentially syntactic sugar for looping through iterables, and applying an expression to each item, typically used to build new lists in just one line of code. The basic syntax for list comprehensions looks like this. First, we have the expression. This is the value you want to include in the list. It can be the item itself, or you can perform an operation on it. Next, we have the loop, where the item represents each element in the iterable. The iterable is the collection you are looping over. Finally, we have the condition, which is optional. This acts as a filter to decide whether the item should be included in the list. If the condition evaluates to true, the item will be part of the resulting list. Let's look at an example using a regular loop, and then we'll rewrite it using list comprehension. This program will create a list of all the numbers from 1 through 10, with each number squared. Here, we have 3 lines of code. First, we're creating an empty list. Then, we're creating a for loop. And then we're writing an expression for what we want each loop iteration to do. Now, let's rewrite the same program by using list comprehension. Let's define a variable called squares and then add square brackets to define a list. Let's say x raised to the power of 2. So, this is our expression. Next, we need to add the loop. Let's say for x in range 1 to 11. So, this line produces the exact same result as what we have in lines 1 to 4. As you can see, this code is shorter and cleaner. Now, we can print this variable. Let's run the program one more time. As you can see, we get the same result using list comprehension. We can also filter items. Let's say we want to print only the squares of even numbers. Let's create a new variable called even squares and set it to this statement. At the end, we'll add a condition to only get even square numbers. If a number divided by 2 has a remainder of 0, it's an even number. So, let's say if x modulus 2 equal 0. Now, if you print this variable, you'll see that we only get the even squares. In Python, there's another data structure called a set, which is essentially a collection that does not allow duplicates. So, a set is an unordered collection of unique items, which means the items that we have in a set are not in sequence, so we cannot access them using an index. Sets are commonly used when you want to store items without duplicates and when the order of items does not matter. Set items must be immutable objects. Now, let's see how we can create them. Sets can be created using curly braces or the set function. Let's say we have a set called numbers. I'm going to output this set to the console using the print function. Now, let's see what happens if we try to create a set with duplicate items. In this set, I'll repeat 2 and 3 twice by adding them again at the end. And now if I run the code, then you can see that in the output 2 and 3 print once, even though in the set definition 2 and 3 are repeated twice. The duplicates 2 and 3 were removed from the set because sets in Python automatically remove all duplicate items. It's also possible to create a set that doesn't have any items. To create an empty set, we need to use the set function. Now, we cannot use empty curly braces for this because it would create an empty dictionary instead. So here let's say numbers equals set function. Now, if I run the code, you can see that an empty set has been printed. Since sets are unordered, you can't access elements using an index. However, you can loop through a set to access its elements. Let's say for number in numbers. Now, let's print the number. Here, you'll notice that duplicate numbers appear only once in the output. We can use the len function to get the number of elements in a set. Let's see how we can check if an item is in the set or not. Similar to other compound data types, we can check if an item is in a set or not by using the in keyword. Let's check if the number 4 is in the set. We get true because the number 4 is indeed in the set of numbers. If we change the number 4 to 6, we'll get false because the number 6 is not in the set. We can use the add method to add a single element to a set. Let's add the number 6 to the set. Now, if we print the set, you'll see the new number has been added. We can add multiple items to the set using the update method. Inside the parentheses, you can pass multiple items using square brackets. Now, let's learn how to remove items from a set. To remove an item in a set, we can either use the discard method or the remove method. Let's use the discard method first. Let's remove the number 7 from the set. As you can see, the number 7 has been removed. Now, let's see the remove method. Here, I'll remove the number 6 from the set. Both discard and remove are used to remove an item from a set. However, there's an important difference between them. If the item we're trying to remove is not in the set, discard returns none, whereas the remove method throws an error. Let's remove number 10 using the remove method. Now, if we run the code, we get a key error. However, if we use the discard method, you'll see that no error is thrown, even if the item doesn't exist in the set. We can also remove all items from a set at once by using the clear method. Now, all the elements in our set are gone. So, these are the basics of sets in Python. In the next lesson, let's take a look at set operations. Sets support a variety of mathematical operations, such as union, intersection, difference, and symmetric difference. Let's say we have two sets, set 1 and set 2. Now, we can get a union of two sets using the vertical bar. So, this expression will return a new set that includes all the items that are either in the first or in the second set. Now, let's print this expression and see what we get. You can see we get the union of these two sets. We can also get the intersection of two sets. Let's say print set 1 and set 2. This will return a new set that includes all the items common to both sets. So, the only number that exists in both sets is 3. We can also get the difference between two sets. So, let's say print set 1 minus set 2. In Python, the difference between two sets refers to the elements that are present in the first set but not in the second set. It's essentially what's unique to the first set when compared to the second. The result is numbers 1 and 2, as they are the elements found in set 1 but not in set 2. Finally, we have symmetric difference. This will return the items that are either in the first or second sets but not both. In other words, it returns elements that are unique to each set. So, we get 1, 2, 4, and 5. So, that's it for this lesson. I'll see you in the next lesson. In Python, a tuple is an ordered, immutable collection that can hold multiple items. A tuple is basically a read-only list. We can use it to contain a sequence of objects, but we cannot modify this sequence. They are very similar to lists, but they're ordered and we can't change them. We can also have duplicate values in a tuple. So, let's say we would like to create a tuple called product. The process of creating a tuple is very similar to creating a list, but instead of using square brackets, we use parentheses to define a tuple. Now, we can add multiple values related to this product. For example, let's add some product information. Let's say the product name is laptop. And the category of the product is electronics. And let's say the price of the product is $1,500. Now, let's check the type of the product. For that, we can use the type function. As you can see, it shows that the class is tuple. So, here we can also exclude parentheses. As you can see, even without parentheses, Python still treats it as a tuple. To create a tuple with only one item, you have to add a comma after the item, otherwise Python will not recognize it as a tuple. Let's remove the comma and check the type again. As you can see, now it's a class of string. Now, let's take a look at some methods related to tuples. Python has two built-in methods for working with tuples. We have the count method and we have the index method. So, we can find the count of how many times a value appears. Let's count how many times the value laptop appears. So, let's say print product dot count laptop. So, we get 1. We can find the position of an item using the index method. So, we get 0 as the index of laptop. As I told you, tuples are immutable. We cannot change them. So, if I try to modify product of 0 and set it to a new item, we immediately get this warning. And if we run the code, we get this type error. Tuple object does not support item assignment. For this reason, unlike lists, tuples do not have methods to add new objects or remove existing ones. Similar to lists, we can use a for loop to iterate over all of the contents within a tuple. And we can also check to see if a certain value exists within tuple using the in operator. We can also unpack these tuples, so we can define 3 variables like name, category, and price and set it to product. And then we can print these variables individually. Now, what if we want to delete the entire tuple? In order to do this, we can use the del keyword. Now, let's print the product tuple. We're getting a name error, which means the collection has been deleted. Now, you might be wondering when to use tuples. We use tuples when you have a collection of items that should remain unchanged, need to return multiple values from a function, or want to use a sequence as a dictionary key. In Python, a dictionary is a collection of key-value pairs, where each key is associated with a value. So, when I say that we'll be working with key-value pairs, these are 2 linked values where the key is a unique identifier, where we can find our data, and the value is that data. Dictionaries are ordered, changeable, and do not allow duplicates. Let's create a dictionary where the country names are the keys and their corresponding currencies are the values. So, let's define a variable called currencies. Then we need a set of curly braces. Inside the curly braces, we can add the key value pairs like this. Let's say we have the USA as a key. So, in order to associate a value with a key, we'll follow the key with a colon and then add the value. So, let's add $ for the value. In this example, I'm using a string for both the key and the value. In Python, we can only use immutable types for the keys, so quite often we use strings and numbers. But the value can be of any type. Now, to add another key value pair, we'll separate each with a comma. So, let's go ahead and add a few more key value pairs. Now that we have a dictionary, we can easily look up the value that corresponds to a specific key, just like accessing an item by its index. Let's say I would like to print the currency of Japan. To print a value from the dictionary, we can type currencies followed by square brackets. Inside the brackets, we just pass the key we're looking for. In this case, the key is Japan, because we want to get Japan's currency. Now let's run the program, and we can see that it returned the value associated with the Japan. So, what happens if we try to access a key that doesn't exist? For example, let me try accessing the value for the key Canada. So, when we run this, we'll see a key error because Canada isn't in the dictionary. Throwing an error when a key doesn't exist might not always be what we want. Sometimes we might prefer to return none or a default value instead. For that, we can use the Dictionaries get method. If we run this, this will return none, and we will not get an error. And we can also specify a default value for keys that don't exist. So, to do this, we can just pass the default value that we want as a second argument to this get method. I'll add a comma here and then put in a string that says not found. Let's run this again. Now, we can see that for a key that doesn't exist, it returns not found. So, let's look at how we can add a new entry to our dictionary. Let's add Canada to our dictionary. For that, we can use the update method. So, let's say currencies.update. Within the parentheses, we'll add a set of curly braces. Now, let's add Canada as the key and the Canadian dollar as the value. Now, if we run this, we get the value Canadian dollar. We can also use the update method to update an existing value. Let's say we want to change the currency of the USA to US dollar. So, currencies.update parentheses, curly braces, then add the key USA, colon, and then we can give the new value US dollar. Here, let's change this to USA. Now, let's run this program one more time. As you can see, the currency of the USA has now been updated successfully. If you want to see how many keys we have in our dictionary, then we can just print out its length with the len function. This will return 6 because we have 6 items in the dictionary. If we want to see all the keys in the dictionary, we can simply print currencies.keys. So, this will print only the keys. We can also print just the values using the values method. If we wanted to see the keys and values, then we could use the items method. And this will print your entire dictionary. Now, let's see how to loop over dictionaries. Let's say for key, comma, value in currencies. Now, in order to loop through the keys and values, we'll need to use that items method. So, here let's say .items. And then let's print the key and value. Now, let's run the code. So, we iterated over the entire dictionary. Now let's say that we wanted to delete a specific key and its value. For that, we use the del keyword, which stands for delete. Let's say we wanted to delete China's currency from the dictionary. Now, if we run this, we can see that China has been removed. Another way to remove a key and its value is by using the pop method. Inside the parentheses, we just need to pass the key we want to remove. So, let's say we want to remove India. You can remove the most recent key value pair from a dictionary using the pop item method. With pop item, you don't need to pass in a key. In our dictionary, the most recent key value pair is Canada, which is why it was removed. Finally, we have the clear method, which removes everything from the dictionary. In this lesson, I'm going to explain dictionary comprehensions in Python. Dictionary comprehensions are very similar to list comprehensions, except they work with dictionaries. The basic syntax for dictionary comprehensions looks like this. The key in the resulting dictionary is defined by key, while the value can be any expression that may use the key, value, or other variables. This loops through an iterable that provides both a key and a value in each iteration. This is a filtering condition. The dictionary will only include key-value pairs for which this condition evaluates to true. So, let's see an example. Let's say we have a dictionary of student scores. So, we have different student names as the keys and their corresponding scores as the values. Now, let's say we want to create a new dictionary containing only students who scored more than 75. Let's give this dictionary a name. We'll call it High Scores. So, according to our syntax, first we have the key, colon, then value. And then let's say for key, comma, value, in, and then our iterable of student scores. Since we're working with a dictionary, we're going to use the items method. And at the end of this, we need to add our condition. So, we're looking for students who scored 75 or higher. Let's say if value greater than or equals 75. Now, let's print this. As you can see, we now have a new dictionary that only includes students with scores of 75 or higher. Let's say we want to create a new dictionary where a score of 75 or higher is marked as pass, and anything below 75 is marked as fail. For this, we can add an if-else condition to our expression. Let's say we have a new dictionary called exam results. Now, let's copy and paste this. So, here, we can remove this condition. Now, we need to update this expression. So, let's say pass if value greater than or equal to 75. If not, let's say else and then fail. Now, if we run this program, we get this new dictionary. In this lesson, we're going to learn membership operators in Python. Membership operators in Python are used to test whether a value or variable exists within a sequence, such as strings, lists, tuples, sets, and dictionaries. There are two membership operators in Python, in and not in. The in operator checks if a value exists in a sequence, and the not in operator checks if a value does not exist in a sequence. Let's create a variable called course and set it to learn Python programming. So, now let's say if I want to find this uppercase L, whether it is present or not inside this string. Let's say print, and inside the parentheses we'll pass an uppercase L, and then we will use the in membership operator, and then our string variable name, course. Now, if we run this code, we get true as a result. That's because we have found uppercase L right at the start of the string. Now, what if I change this character to a lowercase l? So, when I run this code, since the lowercase l is not in the entire string, we get false. What if we use the reverse of this membership operator? Let's add not in over here. This means we're checking whether this lowercase l is not present in this string. As you can see, this time we get true. The in and not in membership operators are opposites. If one operator returns true in a given condition, the other will return false for the same condition. Let's go over another example. Let's say we have a list of programming languages. Now, within this list, we need to check if a particular programming language is present or not. Let's check if Ruby is present in the list or not. If we run the code, we get true. Now, let's check another programming language. Let's check JavaScript. Now, we get false because JavaScript is not in our list. And much like the first example, we can do the opposite. Let's say JavaScript not in programming languages. You can see now we get true. So, these operators are very useful for conditional statements and loops, making it easy to manage and manipulate collections of data in Python. The Walrus Operator, introduced in Python 3.8, is also known as the assignment expression operator. It's a colon followed by an equal sign. It allows you to assign a value to a variable as part of an expression, making your code more concise and sometimes more readable. Let's say we have a variable called Sunny and set it to false. Now we can print this variable. If you run this code, we get false. Now, it would be great to combine these statements. For example, we could say that the weather is sunny by setting sunny equals false, and then printing it to the console in a single line of code. Normally, we can't achieve this using the standard assignment operator, so we can use the Walrus operator. Let's add a colon before the equal sign. Now we have the Walrus operator. Let's run the code. So, as you can see, we get false. Now, let's see another example. In this example, we have a list of numbers. We check the length of the list, and if it is not empty, we print a message displaying the number of items in the list. Let's run this program. So, we get the list has 5 items. Now, let's rewrite this program using the Walrus operator. So, let's say if n, then the Walrus operator, and then len mylist greater than 0. Inside the if statement, let's use the same print statement. So, we write the same program with fewer lines of code using the Walrus operator. The zip function in Python is a built-in function that takes 2 or more iterables and aggregates them into a single iterable of tuples. Each tuple contains elements from the corresponding position in each of the input iterables. Here we have 2 lists called list1 and list2. Let's say we want to combine these 2 lists into a single list of tuples. Let's create a variable called combined and set it equal to the zip function. The zip function can take multiple iterables, so we'll pass in list1 and a list2. At this point, the variable combined is a zip object. We can convert it into a list by typecasting it with the list function. Now let's print this. So now we have a list of tuples, and each tuple is storing a pair of elements from our two lists. In this section, I'm going to explain how functions work in Python. A function is a reusable block of code that performs a specific task or set of tasks. They help us divide a large program into smaller chunks so that it's easier to understand and change. We create a function using the def keyword, which is short for define. Next, we need to give our function a name. So let's call it greet. The principles of naming your variables also apply to naming your functions. So, functions should have names that clearly describe what they do. This makes your code more readable and easier to understand. In Python, the convention for naming functions is to use lowercase letters with words separated by underscores. Don't use Python's reserved words or built-in function names as function names. After the name, we need to add parenthesis. And then we'll add a colon. So, if you go down to the next line, you can see our cursor is now indented. Code that is indented under a function belongs to that function and will only execute when the function is called. Now, it is possible to write a function and not have any code in it. But we can't leave it completely blank. If we want to fill this function in later, then we can use this pass keyword. The pass keyword in Python is used to indicate an empty code block, serving as a placeholder that prevents errors from occurring when no action is needed at the moment. However, in this case, we want to print a message. So let's remove this pass keyword and let's say print hello. Let's add another print statement. Both these lines belong to this function because they're indented. Now let me run this code. And we don't really see anything. This is because defining a function won't do anything in itself. So, to bring the function into action, we need to call it. To call this function, all we need to do is type the name of the function, which is greet, and then add a set of parentheses. Now, let's run the code. So, we get these two messages on the terminal. Here's how we define a simple function in Python. We start with the def keyword, followed by the name we choose for the function, and then include empty parentheses to indicate that the function doesn't require any input. After that, we place a colon, and on the next line, we write the code that the function will execute whenever it is called. One thing to remember when we create a function is that we need to define a function first before we can call it. For example, this code won't work. As you can see, we get a name error. So, always remember to define a function before you use it. Function parameters are values that are provided to a function when it is called. Let's say we want to include the user's name in a welcome message. To do this, we can use parameters. When defining a function, we list the parameters inside the parentheses. In this case, we'll add a name parameter to customize the message. Now, when calling this function, we need to provide the name value. We refer to it as an argument. So, let's pass Lucy for the name. Now, let's change this print statement. So, I'm going to convert this to a formatted string. Now, here, I'm going to add the name parameter like this. Now let's run the program. And this is what we get in the terminal. Let's go step by step to see how this function works. When we call the greet function with the argument Lucy, it is passed to the name parameter inside the function definition. Then the name variable is assigned the value Lucy. Finally, the statements inside the function are executed. We can reuse this function and call it with different arguments. Let's also greet Mike and Jennifer. Let's say greet Mike, and then Jennifer. Now let's run the code. Here we greet 3 different users using the same function. As you can see, we didn't modify the function itself. We simply passed different arguments when calling it. With arguments, you can pass more than one value to a function. So let's say I want to pass Lucy as the first name and Anderson as the last name. If we run this program, we'll get an error because the number of arguments doesn't match the number of parameters. We're passing 2 arguments, but our function is only set up to accept 1 argument since it has only 1 parameter. Here, we need to add 2 parameters. Let's rename name to first name and add another parameter called last name. Now we need to update this print statement. Let's change name to first name. Then add another pair of curly braces and include last name. Now let's run this code. So we get hello Lucy Anderson, how are you? In this lesson, I'm going to explain the return statement in Python. The return statement is used in functions to send values or objects back. These are known as the function's return value. Let's define a function called addNumbers. And we'll set up 2 parameters for this function. Let's say num1 and num2. Inside the function, let's say result equals num1 plus num2. And then at the end, we can return the result. When we call this function, we need to pass 2 numbers as arguments. So let's pass 10 and 20 as arguments. Now, let's run this. So, we cannot get any result. When we return the result after adding num1 and num2, it's going to return the result back to the caller. This is essential for functions that need to give back results to the rest of the program for further use or processing. In this case, to see the returned value, we can assign it to a variable like this. Here, let's say result equals addNumbers. And then we can print the result variable. Now, let's run this again. Now, with the return value, there is another way in which we could write this that uses less lines of code. So, instead of returning a variable called result, we can just return num1 plus num2. Now, let's run this. So, the result is still the same. We already learned the return statement ends the function's execution when it is encountered. Any code after the return statement within the function will not be executed. As you can see, we didn't get the print statement here. If a function uses return without specifying a value, it will return none by default, indicating that the function did not produce a meaningful result. In Python, arguments are the values you pass to functions when you call them. There are different ways to pass arguments to a function, such as using positional arguments, keyword arguments, and default arguments. Let's say we have a function called personDetails. This function accepts two arguments, name and age. If we run this code, we get this output. Lucy is 30 years old. In this example, we're using positional arguments. If we change the order of these arguments, we'll get a different result. If we run this code, we get 30 is Lucy years old. So, when using positional arguments, we need to remember that the order is important. In Python, positional arguments are arguments that are passed to a function in the same order as the parameters are defined in the function's signature. The function matches the arguments to the parameters based on their position, not by name. Now, if we were to use keyword arguments, then the order of the arguments doesn't matter. However, with each argument, we need to precede it with a unique identifier. And that identifier is the name of the parameter we want to associate each argument with. So, here let's say age equals 30 and name equals Lucy. Now, the order of the arguments doesn't matter here. So, let's run the code. Now, we get the correct output. So, that's all about keyword arguments. Default arguments allow you to define default values for parameters. If no value is provided for a parameter when the function is called, the default value is used. This is useful for creating flexible functions with optional parameters. So, let's make the age parameter optional. Let's assign a default value to the age parameter. So, we set it to 25. Now, we can remove this age argument. So, let's run this code. Now, we get Lucy is 25 years old, but if we pass the second argument here, now we get Lucy is 40 years old. Keep in mind that all optional parameters must come after the required parameters. In this lesson, we'll discuss the use of args parameter. In Python, args is used in function definitions to allow the function to accept a variable number of arguments. The asterisk symbol before args means that args will be a tuple of all additional arguments passed to the function. Imagine we have a function that calculates the total price of items in a shopping cart. So, the number of items can vary, so using args allows the function to handle any number of item prices. Actually, the args portion isn't as important as the asterisk. Args is short for arguments, and you can really name this whatever you want. Just be sure that you have this asterisk, because with this asterisk, we're doing a form of packing. For example, we can rename args to something like item prices, or choose any name you prefer. To calculate total price, let's add a new variable called total and initialize it to 0. And then we will need to iterate through all of the items within our tuple. So, let's say for price in item prices. Then we'll say total plus equals price to add each price to the total. This loop will work for any number of prices passed to the function. And at the end, when we escape the for loop, we will return our total. Now let's call this function. let's say total price equals and then the function name. First, let's pass two arguments. After that, let's print the total price. Now, if we run this program, we get the total price of 10.8. Now, let's pass in a few more arguments. Let's pass in 5 arguments this time. So, now we get the total price is 42.89. This example shows how args makes it easy to handle a flexible number of inputs, which is common in real-world applications like processing shopping carts and summing up scores or aggregating data. In Python, kwargs, short for keyword arguments, allows you to pass a variable number of keyword arguments to a function. These arguments are stored in a dictionary, where the keys are the argument names and the values are the argument values. When you define a function with kwargs, it can accept any number of keyword arguments. It's similar to args, except args accepts a varying number of positional arguments and packs them into a tuple. Let's say we have a function called display user details. Here you don't necessarily need to name this parameter as kwargs. You could name this as something else. But the important thing is that you need to use double asterisks before it. Now, we need to iterate through each key value pair in the dictionary. To do that, we can use a for loop. So, let's say for, then key, comma, value, and then in, and the name of our dictionary, in this case, kwargs, and then dot items. And then we will print each key and value using fstring. Now, let's call this function. Here, let's pass name equals Alice, age equals 25, and city equals New York. If we run this program, we get the following output. Kwargs allows a function to accept an arbitrary number of keyword arguments, which are collected into a dictionary. It provides flexibility when defining functions that might need to handle optional or varying named parameters. This feature is useful in scenarios like configuration settings, user profiles, or any situation where the exact set of input parameters might change. In Python, variable scope refers to the region or context within a program where a variable is defined and can be accessed. A variable defined inside a function is in the local scope. This means it is only accessible within that function. Let's say that we have a function called myFunction. Inside this function, we have a variable called x that is set to 10. So, this variable is known to have a local scope because it's declared inside of a function. It only exists inside of this function. If we call this function, we get 10. Now, let's attempt to access this variable from outside of our function. Let's print x to see what happens. As you can see, we're getting a red underline indicating an unresolved reference for x. And if we run this code, we get this name error. Name x is not defined. So, local variables are declared inside of a function and they have a local scope, which means they don't exist anywhere else. A variable defined outside of any function or block is in the global scope. Now, let's define a global variable x as well. If we run this program, you can see that we now get 20. So, it is entirely possible to have both a global and local version of the same named variable. If I was to print variable x from outside of this function, it's going to print my global version of x. However, if I print variable x inside of that function in which it's created, we're going to use the local version before the global version of x. So, let's call the function again. Now, if we run the program, you'll see that it returns 10 and 20. Now, let's comment this local variable x. Let's run the code one more time. Now, we get 20 and 20. If you use a variable inside a function, the function will try to use the local version first. If there isn't one, it will use the global version instead. Python will follow this rule known as the LEGB rule. You first use local variables, followed by enclosed variables, then global ones, and finally any built-in variables in that specific order. In conclusion, a local scope is confined to the function where a variable is defined, meaning the variable can only be accessed within that function. On the other hand, a global scope allows a variable to be accessed from anywhere in the code, outside of any function. In Python, exceptions are events that occur during the execution of a program and disrupt its normal flow. They typically arise when Python encounters an error that it cannot handle. When this happens, Python raises an exception, which, if not handled by the program, can cause it to terminate. Here, we ask the user to input a number and then convert it into an integer. We have a variable called number and assign the converted value to it. Next, we will divide 100 by this number and display the result on the console. So, let's try to execute this program. So let's enter 10. When I enter 10, as you can see, everything works smoothly. Now, let's run the program again. This time, let's enter 0. Now, when I enter this, the program is going to throw an error. We get a 0 division error. The reason we're getting this error is that dividing any number by 0 doesn't make sense in mathematics. It's impossible to divide something into 0 parts, so Python stops the program and gives an error to tell you something is wrong. Now, let's run the program one more time. This time, let's enter a word. Let's say test. Here we're expecting a number, but the user inputted a string, which causes a value error, and as you can see, the program is terminated. Anytime we accept user input that is considered dangerous code, because a user can type in anything. If you're developing a real-world Python application, you don't want something like this to cause your program to fail. So, you want to be able to handle all these different situations. And in order to handle them, we can use something called a try except block. So, we're going to surround this code within a try block. Now, let's type try and add a colon, and then indent any code underneath it. Now, if an exception occurs, we can handle it using the except block. Let's say the user enters the number 0. We can handle it like this. Let's say except 0 division error. Now, we can print a message like number cannot be 0. Let's see if this works. So, we get the message number cannot be 0, and our program doesn't crash. If we add another print statement after this try except block, we can confirm that our program runs flawlessly. In this example, because we are handling this exception properly, this statement will be executed. Let's run the program one more time. Let's enter 0. As you can see, we get the both messages. So, if we didn't handle the exception, this line would not be executed. We also have an optional else clause here. Let's say else. And what we put inside this block will be executed if no exception is thrown. So let's print our result only if there are no exceptions. Let's run the code. Let's enter a number 20. If there are no exceptions, we just execute whatever inside the else block. Now let's remove this line. So now let's say somebody type a word. As you can see, our program crashed again. To solve this problem, we can add a second except clause. As you can see, this time we need to handle the value error exception. So let's say except value error. Here, let's print a message. Please enter only numbers. Let's run the program. I'll type in the word test. So we get the message, please enter only numbers. When handling the exception, we can optionally define a variable that will include the details about the exception. To do this, after each of the except block definitions, we'll add as and define a variable like x. Now, let's print x. Additionally, I'll print the type of the exception. Now, let's run the program. Let's enter word test. As you can see, we get the message invalid literal for int with base 10, and the exception type is value error. This is an additional way in which you could handle an exception. We can also catch all the exceptions. Let's say except exceptions. Here, let's print this message, something went wrong. Let's run the code. Let's enter 0. We get the message, something went wrong. Now, let's run the program one more time. This time, let's enter a word. As you can see, we get the same message. Now, this is actually considered bad practice. We want to tell the user what went wrong exactly. Exceptions will catch all exceptions, however it's too broad of a clause. So, it's good practice to tell the user what went wrong exactly. We have another clause called finally. The finally block always executes whether an exception occurs or not. It's typically used to perform cleanup actions that need to run under all circumstances. This clause always at the end. So, this is the perfect place to close files, database connections, and so on. We haven't covered opening and closing files yet, so we won't do that here. Instead, let's just print something. So, let's print this message. This will always execute. Let's run the code. Let's enter 0. As you can see, we get the two messages, number cannot be 0 and this will always execute. Now, let's run this code one more time. Let's enter 20. So, this will give us a result, and as you can see, the finally clause will still execute. In this lesson, I'm going to explain match case statements in Python. The match case statement, introduced in Python 3.10, is a control flow structure used for pattern matching. It allows you to compare an expression against a series of patterns, and when a match is found, it executes the corresponding block of code. It's similar to switch case statements in other languages, but is more powerful due to its ability to match complex patterns. Let's see an example. Here we have a function that checks HTTP status codes. As you can see, the code contains many elif statements. Basically, this works fine. But the thing that makes this less than optimal is that I'm using this elif code is equal to a numerical value over and over and over again. Having one elif statement for each code seems kind of annoying to write every single time. We can write the same thing in a simpler way by using the match case statement. First, we can type keyword match and then the value we want to match on, which is the code variable, and then colon. After that, we can specify different kinds of cases. For example, a case for status code 200. So let's say case 200. And if that is the case, we have colon and we are running some code inside of it. And then we can check for different cases and run some code for all the different possibilities like this. If none of the conditions match, we have an underscore case, which acts like an else statement. Here, I'm going to check for status codes 200 and 403. Now, let's run the code. As you can see, we get OK and forbidden as the result. Now, let's try 999. Since there's no matching case for that value, it should execute the underscore case. If Python doesn't find a match for any of these cases, it will run the underscore case. Match case statements are mainly useful for checking one specific value from a long list of possibilities. But you'll usually see if elif statements being used, which is totally fine. If you prefer to stick with if elif else statements, that's perfectly okay too. Using match case isn't something you absolutely have to do. Thanks for watching. See you in the next lesson. In this lesson, we'll be talking about classes and objects in Python. So, what are they? Let's start by understanding objects. Objects are simply things you can see around you, like a phone, a book, or a table. Every object has a state and behaviors. For example, the state of a phone could include its model, color, and price. Its behaviors might include making calls or sending messages. In Python, objects are instances of a class, which means they are created from a class. A class is like a blueprint that defines the structure of an object. To create an object for something like a phone, we first need to define a class for it. In a class, you define the states and behaviors of the object. Python uses attributes to represent the state of an object and methods to represent its behaviors. When a function is tied to an object, it becomes a method of that object. Classes are user-defined data types, allowing you to build custom objects beyond the basic data types, like integers, floats, and strings. Now, let's see an example. We will create a class called phone. So, we start with the class keyword. Next, we have the class name. Let's call it phone. A common naming convention with class names is that they should start with an uppercase letter. To name our variables and functions, we use all lowercase letters and we separate multiple words using an underscore. But to name our classes, we use a different convention. If our class name consists of multiple words, the first letter of each word should be capitalized, and we shouldn't use underscores to separate the words. Next, we add a colon to indicate the start of a block of code. In this block, we'll define all the functions related to this class. I will leave this empty for now. If we run the code as is, it will cause an error. To prevent the error, we can use the pass statement. So, now we have a simple phone class without any attributes or methods. Next, let's see how to create instances using this class. When I say creating an instance or creating an object, I'm referring to the same thing. They both mean making an individual example of the class. To create a phone object, we call this class like a function. This creates and returns a phone object, which we can assign to a variable. Now we can assign attributes to this instance. Let's say we wanted phone1 to have a brand and a model. So I could say phone1.brand equal is to Apple. And then I could say phone1.modal equals iPhone 16 Pro. Let's create another object from the phone class. Let's give this object the same attributes but with different values. If you print the brand of both instances, you'll see Apple for phone1 and Samsung for phone2. Now, let's say we want to set all this information for each phone when it's created. Instead of doing it manually like we just did, we wouldn't want to set these variables every time by hand. It's not only a lot of code, but also prone to mistakes. Doing it this way defeats the purpose of using classes, as we wouldn't get much benefit from them. To make these set up automatically when we created the phone, we'll use a special method called init. So, now, inside of our phone class, I'm going to create this special init method. Let's say def :init :. This is a special method that we call a magic method. In other programming languages, it is known as the constructor. When we create methods within a class, they receive the instance as the first argument automatically. By convention, we call this instance self. But you can name it whatever you want. However, it's a good idea to follow convention and use the word self to represent the instance within the class. After self, we can specify what other parameters that we want to accept. So, let's pass brand and model. Now within our init method, we're going to set all of these instance variables. Let's say self.brand equals brand, and self.model equals model. Now, these don't need to be the same as our parameters. So, for example, I could change this. Self.make equals brand. But I usually like to keep these similar if possible. So, I'm going to set that back to self.brand equals brand. So now, when we create an instance of our phone class, we can pass in the values we defined in the init method. Our init method takes the instance, which we refer to as self, along with the brand and model as parameters. When we create an instance of the phone class, the self parameter is passed automatically. We only need to provide the brand and the model. So, I'll pass in all the same information we added manually earlier. We need to pass these values in the correct order. So, what would happen on this line when we create this phone object? When you run the program, the init method will run automatically. This means phone1 will be passed in as self, and all its attributes will be set. So, phone1 brand will be set to Apple, and phone1 model will be set to iPhone 16 Pro. The same thing happens with the phone2 instance. Now that we have that an init method in place, we can delete these manual assignments. And you can see by deleting that we got rid of a lot of code. Now, if we run the program, you'll see it works exactly like before. We can also add methods to the class. Let's create a method called makeCall. Every instance method in the class should have at least one parameter, always called self. In this method, I'll add another parameter called number. By using the self parameter, we have a reference to the current phone object. This allows us to access and set the brand and model values within the method. Inside the method, let's say calling number from using self.brand, self.model. Using self, we can access the current object's attributes or call other methods within the same object. Now, let's call this method. Remember that we need parentheses here because this is a method, not an attribute. Inside the parentheses, we need to pass a value for the number parameter. Let's also call this method using the other instance. If we run this program, we'll see the output showing the values for both phone1 and phone2, based on the attributes we've set. In conclusion, a class serves as a blueprint for creating objects. It defines attributes that describe what an object is or has, and methods that determine what an object can do. This structure allows for organized and reusable code. Let's say we have an object, and we're not sure if it's an instance of a given class. We have a function called isInstance for that purpose. Let's check if these phone objects are instances of the phone class. Let's say print isInstance. Inside the parentheses, we need to pass two arguments. The first is the object we want to check, and the second is the class. Let's do the same check for the phone2 object. If we run the program, you'll see we get true. So, clearly, these two objects are instances of our phone class. However, if we change the class to string, you'll see that we get false. So, it's clear that these two objects are not instances of the string class. This is how we check if an object is an instance of a class in Python. In this lesson, we'll discuss class variables in Python. In the last lesson, we defined two attributes for our phone object in the init method of the phone class. These attributes are known as instance attributes. In other words, these attributes belong to phone instances. Now, whenever we create a new phone object, this phone object will have these attributes by default. Every phone object can have different values for its attributes, as we saw in our previous lesson. We can also define class variables. A class variable is different because it's declared inside the class, but outside of the init method. And these variables are the same across all instances of a class. Now let's create a class variable. Let's call it Network Provider. Using this class variable, we can set a default network provider for all instances of the class. I'm going to set the network provider to Global Telecom. Now that we have a class level attribute, we can access it either through a class reference or an object reference. Here we have two phone objects. We can use these object references to get access to the class variable. Let's say phone1.networkProvider and phone2.networkProvider. However, we can also access this class variable directly through the phone class. Let's say phone.networkProvider. Now we can print these statements. Now let's run the program. As you can see, I can access this class variable from both the class itself and from both instances. Now I'm going to update the class variable's value using the class reference. So here, let's say phone.networkProvider equals to US Cellular. Now, if we run the program, you'll see that it updated the network provider for the class and all its instances. When working with class variables, you can access them through any instance of the class, such as phone1 or phone2. However, it is considered good practice to access class variables using the class name itself, rather than through an instance. This approach improves code clarity and readability. When someone looks at this print statement, they can immediately recognize that network provider is a class variable, even without examining the class definition. If we access them using instances from this class, we can't tell if network provider is an instance variable or a class variable. Therefore, using the class name to access class variables is a more explicit and maintainable approach. Previously, we learned that instance methods in a class automatically take the instance as the first parameter. By convention, we were calling this self. We can call these methods using an instance of the class. However, we also have class methods. A class method allows operations related to the class itself. Now, let's look at how to create a class method. So, I'm going to create a new class method called changeNetworkProvider. And I'm going to call its first parameter CLS, which is short for class. By convention, we call this CLS. We can't use the word class as the variable name here because the class is a keyword in Python. Here, I will add another parameter. Let's call it provider. To make this a class method, we need to decorate it with @classMethod. This is called a decorator, and it's used to extend the behavior of a method. So, this is all you have to do to create a class method in Python. Inside this method, let's say cls.networkProvider equals provider. If we run the program, you'll see that all of them are set to Global Telecom. The reason for this is because we have a class variable defined here. Now, let's say we want to change the network provider to something else. We can do that using this class method. To call a class method, you take the name of the class followed by the class method. So, let's say phone.changeNetworkProvider. This method automatically accepts the class. So, we don't need to pass that in manually. But we need to pass a value for the provider parameter. I'll pass US Cellular as the value. Let's run this one more time. When we call this class method, we can access or modify class data. In this case, we are updating the class variable for the network provider. So, this is the same as what we did in the previous lesson. But now we're using this class method to do that instead. Instance methods are ideal for performing operations on specific instances of a class, as they can access and modify instance-specific data. On the other hand, class methods are better suited for handling class-level data, or when you need access to the class itself, such as when working with class variables. This distinction ensures that each type of method is used in the most appropriate and efficient way. So, now that we looked at class methods, let's talk about static methods. When working with classes, instance methods always pass the instance itself as the first argument. Class methods, on the other hand, pass the class as the first argument. But with static methods, nothing is passed automatically. Not the instance, not the class. Static methods are used when you have a function that belongs with the class logically, but doesn't need to work with the class or instance data. Let's say that we wanted a simple method that would validate the phone number. Let's call this method isValidNumber. Inside the parentheses, I'm going to pass a parameter called number. To validate the phone number, let's say it needs to be all digits and exactly 10 characters long. Inside this method, let's say return number.isDigit and number length equals 10. So, this method has a logical connection to our phone class, but it doesn't actually depend on any specific instance or class variable. So, we can convert this method into a static method. To convert a method into a static method, we use the static method decorator. Now, let's call this static method. Let's say phone.isValidNumber. Inside the parentheses, we need to pass the phone number that we want to check. Now, let's run the program. You can see we get true, so this is a valid phone number. Now, let's pass another number. This time, we get false, because our number length is not equal to 10. Now, let's pass another number. Now, let's run the code one more time. As you can see, we still get false because the number must consist entirely of digits. Sometimes developers write instance or class methods that should actually be static methods. A clear sign that a method should be a static method is when you don't access the instance or the class anywhere within the method. You can see that I'm using self and CLS in these methods. But if I'm not using the instance or class anywhere within these methods, then they likely don't need to be instance or class methods. You might want to consider whether it would be appropriate to use a static method in that context. In this lesson, I'm going to explain inheritance in Python. Inheritance allows a class to inherit the attributes and methods from another class. In this example, let's say we want to get more specific and create different types of phones. For example, let's say we want to create separate classes for smartphones and feature phones. Both smartphones and feature phones will have brands and models, which are already part of our phone class. So, instead of copying all this code into our smartphones and feature phones classes, we can just reuse that code by inheriting from phone. First, let's create the smartphone and feature phone classes. After the name of the class, we can put the parentheses here and specify what classes that we want to inherit from. So, in this case, we want to inherit from the phone class. Inside the class, I'll add a pass statement because I want to show you that by simply inheriting from the phone class, we inherit all of its functionality. Right now, even without any code of its own, the smartphone class will have all of the attributes and methods of the phone class. In this situation, we refer to the phone class as the parent, base, or superclass, and the smartphone class as the child, derived, or subclass. Now let's create the feature phone class and inherit from the phone class as well. Now I'm going to create two new objects from these subclasses. Let's say smartphone equals smartphone. Inside the parentheses, you'll see that we need to pass both the brand and the model. So let's set the brand to Google and set the model to Pixel 9 Pro. Let's create another object using the feature phone class. Here, let's set the brand to Samsung and the model to Guru. Even though there's nothing within these smartphone and feature phone classes, we should still have these attributes and these methods. So, let's print the model of smartphone. So, what happens when we instantiate the smartphone object? First, Python looks for the init method in the smartphone class. Since it's not there, Python goes up the inheritance chain to find it. This process is called the method resolution order, where Python searches through parent classes until it finds the method or attribute it's looking for. We can check method resolution order using the help function. Let's check the method resolution order for the smartphone class. Here's the method resolution order. These are the places that Python searches for attributes and methods. When we created the new smartphone object, Python first looked for the init method in the smartphone class. Since it wasn't there, Python then checked the phone class. The phone class has the init method, so Python executed that method. If Python hadn't found the init method in the phone class, it would have looked in the object class, which is the last place it checks. Every class in Python inherits from the object class by default. We're going to learn this object class later in the course. Now, I'm going to call the makeCall function using this feature phone object. As you can see, we access both attributes and methods from the parent class through inheritance. Now, with children's classes, they can have their own attributes and methods. Let's add a new method called BrowseWeb for smartphone class. Let's add another method called PlayRadio for feature phone class. Now, let's call these methods. Inheritance lets you reuse code by inheriting methods and attributes from a parent class, which helps reduce redundancy. This way, you don't have to write the same code over and over. Let's say that when we created the smartphone class, we also wanted to include the operating system name as an attribute. However, at the moment, the phone class only accepts brand and model as attributes. If we want to include the operating system name, we'll need to give the smartphone class its own init method to handle this extra attribute. So, let's do that. Now, along with the brand and model, I'll also add a parameter for the operating system name. So, this init method will replace the init method in the base class. This is what we call method overriding. Now, what if we want to execute the base class constructor inside the child class? We can do this by using the super function. This allows us to call any method of the parent class from within the child class. So, let's go ahead and call the parent class init method. Let's say super dot init. And then we need to pass the brand and model. Now, there are multiple ways of doing this logic here. You can also write this statement like this. Phone dot init. Here, we need to pass the self parameter along with the brand and model. Both methods work for calling the parent class's init method, but I prefer using super because with single inheritance like this, it's easier to maintain. Now that we're letting the phone class's init method handle the brand and model, we can handle the operating system name parameter just like we would in any other class. Now, when we create an instance of the smartphone class, we'll also need to pass in an operating system name. So, let's pass Android for operating system name. To check if this worked, let's print the operating system name. So, you can see why subclassing is useful. It allows us to customize or extend functionality with minimal code changes. In this implementation, we're extending the init method of the phone class to add a new attribute, operating system name, which is specific to the smartphone class. This approach avoids redundancy while enabling specialized behavior for the subclass. In this lesson, I'm going to explain abstract classes in Python. Let's say we have three classes: animal, dog, and cat. The dog and cat classes are subclasses of animal. In the animal class, we have a method called sound, but it's not implemented yet. In the dog and cat classes, we're overriding the sound method to provide our own implementations. The dog class will return woof, and the cat class will return meow. Here, I've created objects for each of the classes. After that, I've called the sound method in every class using these objects. To check if everything works as expected, let's go ahead and run the program. You'll see that calling the sound method on an animal object will return none, while calling it on dog and cat objects will print woof and meow, respectively. Now, let's say we want to prevent a user from creating an object of the animal class. To prevent users from creating an object of the animal class directly, we can make it an abstract class. An abstract class is meant to provide common code for its subclasses, but it can't be instantiated on its own. This can be done using the ABC module, which stands for Abstract Base Class, along with the abstract method Decorator in Python. Let's say from the ABC module, import ABC, all capital, comma, abstract method, which we'll use as a decorator. So make sure to type this exactly like what you see here. The name of the module is all lowercase and the name of the class is all uppercase. Now to make this animal class abstract, we should derive it from the ABC class. And now, with any methods within your animal class, you're going to add this decorator at the top. Now, if we run this program, you'll see a type error. This happens because once a class is made abstract, we can't instantiate it, meaning we can't create an instance of it. One important thing to remember is that an abstract class must have at least one abstract method. To test this, let's remove the sound method from the animal class. We also need to comment out this line because we no longer have the sound method within the animal class. As you can see, this time it runs without an error. Even if a class inherits from the ABC class, we can still instantiate it if it has no abstract methods. For a class to truly be abstract, it must have at least one abstract method. Now, let's add the sound method back to the animal class. We already know that an abstract method is a method with a declaration but no implementation. Any subclass of an abstract class must provide concrete implementations for all abstract methods. If it doesn't, the subclass will also be considered abstract and can't be instantiated. Let's check this as well. Let's remove the sound method from the cat class. We also need to comment out this line because the animal class is abstract, which means we can't instantiate it. Now, let's run the code one more time. As you can see, this time we get another type error. This means that if you derive from an abstract class, you must implement its abstract methods. If you don't, Python will treat the subclass as an abstract class as well. So, abstract classes are useful when you want to define a template or a blueprint for other classes, but don't want the parent class to be instantiated directly. They help to define a common interface for a group of related classes, while leaving the specifics of implementation to the subclasses. In this lesson, we're talking about method chaining. Method chaining in Python refers to the technique of calling multiple methods on the same object in a single statement. This is possible when each method returns the object itself, usually done with self, allowing the next method to be called directly on the result of the previous method. Here, we have a simple car class. This class has 4 methods: accelerate, brake, repaint, and display info. They will all just print a simple message. To call these methods, we need to create a car object. Now, using this car object, let's call these 4 methods. Let's pass 60 as an argument here. Here, I will pass 10. I will pass red for repaint color. Lastly, let's call the display info method. As you can see, we used 4 lines to call these methods. Now, if we run this code, you'll see these messages. Now, with method chaining, we can call multiple methods in sequence, allowing us to execute them one after the other in a single line of code. If we were to rewrite the same code using method chaining, it might look something like this. So that would be car.accelerate followed by brake, repaint, and lastly, display info. But there's one more thing that we need to add when we're using Python to do method chaining. Normally, this approach by itself won't work. In Python, if a method doesn't return anything, it will return none by default. As you can see here, we're getting an attribute error. None type object has no attribute of break. This happens because the method is returning none, and we're trying to chain another method after it. To fix this, we need to return the object itself in each method where we want to use method chaining. Now, each of these methods returns the car object back. If we run the code again, you'll see that we get the correct result. If we have one long method chain like this, it might become difficult to read. So, you can wrap everything in an extra pair of parentheses like this. So, this is more readable, but it still does the same thing. Multi-level inheritance in Python occurs when a class inherits from another class, which itself inherits from yet another class. Think of it like a family tree. A child inherits traits from their parent, and the parent inherits traits from their grandparent. This creates a chain of inheritance, where properties and behaviors are passed down through multiple levels. Let's see an example. First, I'm going to define a class called vehicle. Inside this class, let's say we have a method called start. Inside this method, let's print vehicle started. Now, let's create a child class that will inherit from the vehicle parent class, and we'll call it car. So, any car that we create will have this start method. Inside this class, let's define a function called drive. Here, I'm going to print car is driving. Now, let's create a class for a specific type of car, such as sports car. This class inherits from the car class. Now, inside this class, let's create a method called turbo. And let's print this message, turbo mode activated. This way, the sport car class can access the properties and methods of both the car and vehicle classes. Now, let's create a sports car object. Then, we will simply call the methods using this object. Let's say sportscar.start. And then, let's call the drive method. Lastly, let's call the method sportscar.turbo. Now, if we run the program, as you can see, we get these messages. This example shows how multi-level inheritance allows a child class to access methods from both its parent and grandparent classes, creating a chain of inheritance. In this lesson, we're going to learn multiple inheritance. In Python, a class can have multiple base classes. This means that a child class can inherit methods and attributes from multiple base classes, combining their functionality. So, as you see here, I have defined two classes, vehicle and electric. Vehicle class has one method, start, and it just prints vehicle started. In the electric class, we have a charge battery method, and in this method, we print battery charging. Now, let's create a new class called electric car. Inside this class, I'm going to create a method called drive. Inside this method, I'm going to print electric car is driving. Now, let's say the electric car class needs to access the functionalities of both the vehicle and electric classes. So, we need to inherit both the vehicle and electric classes in the electric car class. Inside the parentheses, let's put the classes vehicle and electric. Now, the electric car class inherits from both the vehicle and electric classes. This is what we call multiple inheritance. Let's create an instance of electric car. Let's say my car is equal to electric car. Now, let's try to access these methods using this instance. Let's say mycar.start. Next, we'll call the charge battery method. Lastly, let's call the drive method. If I run this code, you can see we get all three messages. So, if you need to inherit from more than one parent, you just add that additional class to the inheritance list. The benefit of multiple inheritance is sometimes you have two different classes and you just want to inherit the attributes and methods of those classes just to reuse the code. You can inherit a class from as many classes as you want. Now, let's say the electric class has a method called start, and in this method, we print electric system is starting. As you can see, our vehicle class also has the exact same method name, but both start methods print different messages. Now, here we call the start method. Which start method do you think is going to get called? To check this, let's run the program again. As you can see, we got the vehicle class's start method. This is because we listed the vehicle class first in the inheritance order. When Python tries to execute this line, it first checks the electric car class to see if it has a method called start. If it doesn't find the method, Python will look at the first base class, vehicle. If the vehicle class has the start method, the search stops there. If the vehicle class doesn't have it, Python will then check the electric class. Now, let's change the order of these parent classes. Let's run the program one more time. As you can see, we now get a different output. When using multiple inheritance in Python, the order of the parent classes matters. Python follows a specific order to decide which parent class's method or attribute to use if there's a naming conflict. Always ensure that you list the parent classes in the correct order based on how you want the program to behave. If you list them in the wrong order, Python might use the wrong class's method, which could lead to bugs that are hard to spot. In this lesson, we'll learn about special methods that can be used within our classes. So, these special methods are called magic methods. In Python, these are also known as dunder methods, short for double underscore methods, because they're always surrounded by double underscores. These magic methods are automatically called by the Python interpreter, based on how we interact with our objects and classes. We have already learned the dunder init method. So, Here we have a class called point that represents a point in 2D space. We have the init method, which is surrounded by double underscores on both the left and right. It's called automatically by the Python interpreter when we create a new point object. Now, let's see a few other magic methods in Python. If we print this point1 object on the terminal, we get the name of our module followed by the class name and the address of this point object in memory. We can customize this behavior using the strMagic method. So, let's define the str method inside the point class. Now, inside the method, I'm going to return a string representation of the point object. Let's say point and then add parentheses. After that, I'll add two placeholders. Inside the first placeholder, I'm going to type self.x. And then inside the second placeholder, I'm going to type self.y. Now, if we run the program, you can see we get point 3, 4. Let's see how to check if two objects are equal using a magic method. So, I'm going to create another point object with the exact same value. If we compare these objects like this, you'll see that we get false. The reason we get false is that, by default, the equality operator compares the memory references or addresses of these two objects, not their actual content. In this case, these two objects are referencing two different objects in memory, and that's why they're not equal. So, let's customize this behavior using a magic method. We will define the dunderEQ method to handle this comparison. For parameters, we have self representing the current point object, in this case, point 1, and other, which represents the second point we're comparing. Inside this method, let's say return self.x equals other.x and self.y equals other.y. If this expression evaluates to true, it means these two objects are considered equal. So, if we run this code, as you can see, we get true. Now, let's change the x and y values of point 2. Let's run the program one more time. This time, the result is false, because the x and y values of point 1 and point 2 are not the same. Now, what if I try to check if point 1 is greater than point 2? If you run this program, you'll get a type error because the greater than operator is not supported for instances of the point class. To fix this, we can use another magic method called GT. Inside this method, let's say return self.x is greater than other.x and self.y is greater than other.y. Now, you can see we get true. Let's change the greater than operator to less than. This time, the result is false. So, you don't have to explicitly implement each of these comparison operators. When you implement the greater than magic method, Python can automatically handle other related operators, like the less than operator. Python provides special magic methods that allow us to perform arithmetic operations between objects. For instance, we can add two point objects together by implementing the add magic method, which defines how the plus operator behaves for those objects. Inside this method, let's return new point object. Here, let's say self.x plus other.x, and then self.y plus other.y. Now, let's change this to point 1 plus point 2. If we run this program, you can see we get a new point object. So, magic methods are automatically called by many of Python's built-in operations. They allow developers to define or customize the behavior of objects when we use built-in operations. If you'd like to see the complete list of magic methods available in Python, you can search for Python 3 magic methods online. In this lesson, we'll learn how to use the Property Decorator in Python. This allows us to add getter and setter functionality to our attributes, enabling controlled access and modification of their values. Let's see an example. I'm going to create a class called Circle. When constructing a circle object, we only need a radius. So, let's pass the radius as a parameter. Now, we can create a circle object using this class. Here, we need to pass a value for the radius. Let's pass 5. Now, let's print the radius value. Let's say print circle.radius. So, if we run this program, you can see we get 5. With this implementation, we can assign a negative value to the radius. So, this is not good, because the radius cannot be a negative value, which could lead to invalid data in our program. We can prevent this using the Property Decorator. Let's define 2 methods for getting and setting the value of this radius attribute. First, let's add the getter method for the radius attribute. This method only takes self as a parameter and does not require any additional arguments. Here, we simply return self._radius. The underscore before radius is used to indicate that it is a private attribute of the circle class. By naming the attribute with the underscore, we signal to other developers that this variable is intended for internal use within the class and should not be accessed or modified directly from outside the class. In Python, using an underscore is a convention to indicate that an attribute is intended to be protected or private. Next, I'll apply the Property Decorator to this method. Similarly, we can define the setter method for the radius attribute. Here, we need to pass another parameter, which we'll call new_radius. Now, we need to add a decorator to this method. The name of that decorator starts with the name of our attribute, in this case radius, and then .setter. First, we check if the new radius is less than 0. If this is true, we'll raise a value error exception with the message radius cannot be negative. Otherwise, we'll set the new radius. Now that we have a setter method with data validation, we can set the radius property like a regular attribute within the init method. If we run the program, you'll see that it raises an exception because the radius value is negative. Now, if we change the radius to a positive value, you'll see that we get the correct radius value. The Property Decorator allows us to define methods that can be accessed like attributes. By defining getter and setter methods for the radius property, we can access and modify the radius using attribute-style syntax. In this lesson, we'll learn about polymorphism. The word comes from two parts, poly, meaning many, and morphism, meaning forms. So, polymorphism is the ability to take on many forms. In programming, it allows objects to behave differently depending on their context. Let's look at an example to understand this better. First, we'll create a class called vehicle. Inside this class, we'll define a method named move. Now, I want to make the move method abstract. To do this, the vehicle class needs to inherit from the ABC class, which stands for abstract base class. So, let's import it. Let's say from ABC, import uppercase ABC, abstract method. Here, we need to add a decorator of the abstract method. And we need to have the vehicle class inherit from the ABC class. This will allow us to define move as an abstract method, ensuring that any subclass of vehicle must provide its own implementation of move. Now, I'll create three classes: car, boat, and plane. These classes will inherit from the vehicle class, meaning they'll share the same structure as vehicle, but can also have their own unique behaviors. Since vehicle has an abstract method called move, each of these classes will need to provide their own implementation of the move method. In the move method of the car class, we'll return the string, "The car drives on the road." In the boat class, we will return the string, "The boat sails on the water." In the plane class, we will return the string, "The plane flies in the sky." Now, I'm going to define another function outside of these classes. I'll call this function vehicle move. It will take one parameter, which we'll name vehicle. Inside the function, let's say print vehicle dot move. This will call the move method of the object passed to the function and print its result. Now, let's create instances of these classes. Now, I'll call the vehicle move function 3 times. Each time, I'll pass a different instance as an argument. First the car object, then the boat object, and finally the plane object. Now, if we run the program, we get these 3 messages. In this example, the vehicle move function can take many different forms. and this is determined at runtime. Depending on whether we pass a car, boat, or plane object, the function will call the appropriate move method for that object. This flexibility is what makes polymorphism so powerful. It allows the same function to work with different types of objects seamlessly. In this lesson, we're going to learn duck typing in Python. Duck typing in Python is a programming concept that refers to the principle of if it walks like a duck and quacks like a duck, it must be a duck. In Python, this means that the type or class of an object is less important than the methods or attributes it defines and how it behaves. Rather than checking an object's type explicitly, Python programs often just use the object, trusting that it will behave correctly as long as it has the necessary methods or attributes. In this example, I have two simple classes, duck and dog. Each class has two methods, sound and walk. These methods do different things depending on the class. I also have a function called sound and walk. This function takes an object, like a duck or dog, as an argument and calls its sound and walk methods. As you can see here, I've created an instance of the duck class and passed it into the function. Here, I've also created an instance of the dog class and passed it into the sound and walk function. When the function runs with the dog object, it will call the dog sound and walk methods, which will produce different results compared to the duck. This shows how the same function can work with different types of objects, adapting its behavior based on the object passed to it. With duck typing, we can pass in any type of object into the function, as long as it has the required methods and attributes. For example, if an object has sound and walk methods, it doesn't matter whether it's a duck, a dog, or even something entirely different, like a robot. As long as the object can quack like a duck, the function will work with it. This is the flexibility that duck typing provides in Python. Now, let's remove the walk method from the dog class. If we do this and then try to pass a dog object into the sound and walk function, it will raise an error. This is because the function expects the object to have both sound and walk methods. Without the walk method, the dog object no longer quacks like a duck, and the function won't work as intended. In conclusion, when using duck typing, the class type of an object is less important than the methods or attributes it possesses. As long as the necessary methods and attributes are present, the class type won't be checked. In this lesson, we're going to learn about modules in Python. A module is essentially a file that contains Python code. Modules can include functions, classes, and variables, and they can also include runnable code. The purpose of using modules is to organize code into manageable and reusable sections. We're currently working within our main module. Now, let's create another module. Here in the project folder, I'm going to add a new file and call it Math Operations. Keep in mind, following naming conventions, just like with variables and functions, we use all lowercase letters, and if there are multiple words, we separate them with an underscore. Now, let's add some functions to this module. I'm going to define two functions, add numbers and multiply numbers. So, First function, return the sum of two numbers, and second function, return the product of two numbers. Now, if we want to access this module from our main module, we need to import it. There are a couple of different ways to achieve this. At the top of the main module, let's say import. Then the name of the module, in this case, math operations. Now, to use a function from that module, simply type the name of the module, followed by the name of the function you want to call. So, mathoperations.addNumbers. Here, let's pass two numbers. Let's pass 6 and 4. Now, let's assign this to a variable. Let's call it sum_result. Now, let's use the print function to display this result. Let's run the program. Let's also call the multiply numbers function. We'll use the same numbers here as well. Now let's add another print statement for this. Let's run the program one more time. We've now successfully called the functions from another module in our main program. Here, we can use an alias. It's especially helpful if the module name is long, as it reduces the amount of typing you need to do. Here, we can say import math operations as mo. Now, we can use the alias instead of math operations. If you run this, you'll see we get the same result. Now, we have another way of importing a module. So, we start with from, and then we add the name of the module, which is math operations, and then use the import keyword. Now, if you press Ctrl and space here, we can see all the objects defined in this module. Currently, we have these two functions. If you want to import multiple objects from a module, we can separate them using a comma. So, let's import both of our functions, add numbers and multiply numbers. This way, we can use these function names directly in our main program. We have a shortcut to import multiple objects using an asterisk. This will import all objects. I actually wouldn't recommend using this approach, because if you're working on a project with many modules, you could encounter naming conflicts and accidentally overwrite functions or variables with the same name in the current module. So, don't import all objects like this. Only import the stuff that you need. Python includes a wide range of built-in packages and modules that make it easier to develop real-world applications. This extensive library provides ready-made tools to solve many common problems. When a module is part of Python's standard library, it means you don't need to install anything extra to use it. It's already available. However, to use them in our code, we first need to import them. Think of it like a toolbox that Python gives you right away, so you can solve different problems without needing to look for other tools. It makes programming easier and faster because you can use these ready-made solutions. For a list of all the modules found within the standard Python library, you can use the help function. So, let's type help and pass the word modules inside the parentheses. And then we would need to print this. Here are many of the different modules available in Python. Let's say we want to use the built-in math module. On the top, let's say import math. Now, we have access to everything found within the math module. So, this module contains functions and constant values for use in mathematical equations. Let's go ahead and access something from this module. Within the math module, there's a function called square root. This will return the square root of a number. So, let's check the square root of 16. Let's say math dot square root and then number. Now, let's print this. As you can see, the result is 4. So, how do we know what to use from a module? There's a few ways to find out what's inside of a module. We can use the dir function. With this function, we can get the list of attributes and methods defined in an object. Let's pass the math module into this function. When we run this program, we get a list of strings. In this list, we have all the attributes and methods defined in this module. We can use these attributes and methods in both user-defined and built-in modules when the module is imported into other modules. In the upcoming lessons, we'll dive into 2 commonly used modules, the date and time module and the random numbers module. At the moment, all of our modules are located in the same folder, but let's say our project is getting bigger and bigger. We probably want to organize these modules into subdirectories. So, let's move the Math Operations module into a subdirectory. I'm going to name this new subdirectory Arithmetic Utilities. Now, let's drag and drop this module right here. To convert this subdirectory into a Python package, we need to add a new file called double_init_.py to the Arithmetic Utilities directory. When we add this file, Python will treat the Arithmetic Utilities directory as a package. This file can be empty. If it is empty, it means that all the modules and functions within that package are allowed to be imported. Now, inside main.py, we need to prefix the module name with the name of its package. So, let's say import arithmetic utilities.mathoperations. Here also, we need to prefix these with the name of their package. When you run this program, you'll see we get the same result as before. But this will make the code messy because we'll have to type arithmetic utilities.mathoperations every time. So, to avoid this, we could use the from statement. Let's change this to from arithmetic utilities.mathoperations. Import add numbers and multiply numbers. Now we can simply call these functions. We have another way of doing this, especially if we need to call many functions. The current method could end up being too cluttered. So, we can type from arithmetic utilities, import math operations. Now, here we need to change math operations dot add numbers and math operations dot multiply numbers. This is how we use packages in Python. In this section, we're going to learn how to work with date and time in Python. Python provides two modules for this purpose. The first is the time module, which allows us to work with timestamps. The second is the Datetime module, which provides date and time objects, including attributes such as the year, month, and more. First, let's look at the time module. Now, let's import the time module at the top. So, this time module has a method called time that returns the current date time as a timestamp. Let's print time.time. If we run this code, this is what we get. This floating point number represents the number of seconds after January 1st, 1970, which is referred to as Unix epoch time. We use this epoch as a reference point. To find your computer's epoch, we can use cTime function. This epoch time varies based on your computer and your operating system. As I mentioned before, for Unix-based systems, this is the reference point. So let's print time.ctime, and as an argument, we'll pass in 0. Now, let's run the code. So, this is the date time in which my operating system thinks time began. Now, we can convert the current timestamp to a readable time using the cTime function. Let's say print time.cTime. Inside the parentheses, let's pass time.time as an argument. Now, let's look at datetime in Python. So, to work with dates, we have to import the Datetime module. This allows us to work with dates and times based on our system's date and time. Now, let's say print, and let's say datetime dot, and datetime dot, and the now method. So, we're accessing the Datetime module, there's a built-in Datetime class we have to access, then within that class there's a now method. If we run this, it will give us the current date and time according to my system clock. If we want, we can retrieve just the date. So, let's say print datetime, date, today. If we run this, it will give us only the current date. We can also retrieve just the current time. So, let's say print datetime, datetime.now.time. This will give us only the current time. As you can see, we repeat datetime.datetime several times, so we can import the datetime class from this module. Let's say from datetime, import datetime. Here, we also need to import the date class. Now, we can remove these from the code. For example, if you want to get the year, month, and day separately, you can do it like this. Similarly, if you want to get the hour, minute, and second separately, Now, let's learn how to format the date. The Datetime object has a method for formatting date objects into readable strings. The method is called strftime. It stands for string format time. This method is used to format datetime objects as strings according to a specified format. First, let's create a variable called now and set it to datetime.now. Let's create another variable called formatted date and set it to now.strftime. So, we need to specify the format specifiers here. Let's say present y. This will give us year /%m for month and %d for date. Now, let's print the result. Let's say we want to change the slash to a dash. We can do that like this. So, if you want the month name, you can use uppercase B. You can refer to more details about these format specifiers in the documentation. Here are some of the commonly used format codes. Now, let's take a look at time deltas. Time deltas are simply the difference between two dates or times, and they're extremely useful when we want to do operations on our dates or times. For example, let's create a time delta 3 weeks away, which would be 21 days. Let's say time delta equals datetime dot time delta. Inside the parentheses, we need to pass the duration. Let's say days equals 21. Now that I have this duration of 21 days, I can use this to do some calculations. First, let's get current date. Let's say today is equal to datetime dot date dot today. To get the date 3 weeks from now, let's say print today plus time delta. If we run this code, you'll see it prints out the date that will be 21 days from now. You can also subtract time delta objects to calculate past dates. If I wanted to know what the date was 3 weeks ago, then instead of adding on 21 days, I can subtract 21 days. As you can see, now we get what the date was 3 weeks ago. Right now, we're adding and subtracting a time delta from a date and getting another date as the result. If we add or subtract another date from a date, then we'll get a time delta as a result. Let's see an example of this. So, let's figure out how many days there are until Christmas Day this year. To calculate that, we're going to have to do is subtract the current date from the date of Christmas Day this year. I'm going to create a new variable called Christmas Day. I want to set that equal to datetime.date. So, Christmas Day is December 25th. I'm going to create another variable here, and I'm going to call this days until Christmas. Now, this is going to be a time delta once we run this calculation. And I'm going to say days until Christmas is equal to Christmas Day minus the current date. Now, let's print this variable. You can see that it has 353 days as the total duration between those two dates. And if we want to get just the days, then you can do like this. Let's say days until Christmas dot days. You can also use the total seconds here, and that's a method. So, this will give us the number of seconds between these two dates. In this lesson, we're going to learn how to generate random numbers in Python. Therefore, we must first import the random module at the top. The random module provides access to many useful methods for working with random numbers. This module has a method called random that gives us a random value between 0 and 1. The value can include 0, but it will exclude 1. This means you can get exactly 0, but you'll never reach exactly 1. You might get values like 0.9999, but it will never fully reach 1. Now, let's print that and see the result. So, we get a floating point number. Every time we run this program, we get a different value between 0 and 1. For example, let's say we wanted a random floating point value between 1 and 10. Then we could use the uniform method. Inside the parentheses, we need to pass the range of values. Let's say 1 to 10. If we run this, we get a random floating point number between 1 and 10 every time we run this. Now, if you want random floating point values between the different ranges, then you can change the arguments that you pass into that method. To get random integers, we have a method called randint. And that generates a random integer between two numbers. Let's say 1 and 10. If we run this, you can see we get 3. Now we get 9, and so on. We have another useful method called choice that takes a list or other collection. Let's say we have a list of numbers. If we run the program, it will randomly pick one of the numbers from the list. So, we get 6. Now, we get 1, and so on. We have a similar method, choices, that selects multiple values from this list. So, here, as the second argument after this list, we need to supply a keyword argument that is k. Let's set it to 2. And this returns 2 random items from our original list. Let's take a look at how we can randomly shuffle a list of values. Let's say we have a list of numbers 1 to 10. We can call random.shuffle and pass this list here. When we print this, the order of these items is randomly changed. As you can see, the list is now randomly shuffled. Now let's say that we wanted to get 3 random numbers from this list. Now you might think that we should use the choices method that we saw previously, but this wouldn't really work because with the choices method, it could randomly grab the same numbers multiple times. So, to do this, we're going to use the sample method. Now, this method will make sure that it only selects unique numbers from the numbers list. Let's create another variable called uniqueList. And I'll set this equal to random.sample. And we want to get a sample from the numbers, and we want 3 random unique values. So we'll pass in k as 3. And now let's print this unique list variable. Now let's run the program. As you can see, we now get a random unique list containing 3 numbers selected from the original numbers list. So that's it for this lesson. I'll see you in the next lesson. In this lesson, we'll learn what dunder name is equal to a string of dunder main, why we should use it, and the benefits of using it. Here, we have a module called myModule. In this module, we have a function called greet, and it prints hello. Then, we have our main file named app.py. Now, first, let's see what exactly is the double underscore name. Name is a special variable we use when we interact with modules. It allows us to make a distinction between the modules we import and the modules we do not import. Let's print out this double underscore name variable. Here's what happens when I run this program. You'll see the dunder name value is equal to main. So, what exactly is going on here? When Python runs a script, it assigns the special variable name the value main if the script is the initial module being executed. Now, let's import myModule and check the name variable of myModule. In order to access a variable from another module, we need to type the name of the module, let's say myModule, and then the special name variable of myModule. Now, let's print this. So, when you import a module, this name variable is going to be assigned the name of the module. In this case, it's myModule. Now, let's check the values of the name variable inside myModule. First, we need to comment out these lines. Let's go to my module file. Here, let's import app.py. Now, let's print the name variable. And then print the name variable of the app. Now, let's run the code. As you can see, this time that special name variable of myModule is main, and the special name variable of app is app. The reason for this is that the app module is no longer being run directly by Python. It's being imported as a module. But myModule's name is main because Python is running this file directly at this time. Now, let's remove these lines from myModule. Let's go to our app module and uncomment this import. Now let's see why this is useful. Here, let's call the greet function. Let's say myModule.greet. If we run this code, you'll notice that we'll get the output written twice in the console. This is because when you import a module, all the code in the module gets executed, which means it executes the function definition, and then it also executes the function being called. So, even if we didn't call this down here, it's going to run that print statement no matter what. And that's not something we really want. We just want the user to be able to use it without having these side effects, such as the double print statement. To resolve this, we can add an if name equals main function to the myModule. Inside this function, let's add the function call. Now, if I go back to the app file and if we run the code, you'll see it's still going to run myModule, and this time we only get one print statement. The reason we're now getting only one print statement is that we have added a check. The function call will only run if name equals main. This means the function will only execute if the module is run directly, and it won't run if the module is imported into another file. So, we can place all the statements we want to execute when this module is run directly inside the if name equals main block. However, it's better practice to define a main function and place the code that should run directly inside it. Then, you can call main inside the if name equals main block. Let's define the main function here. Inside this main function, we can define what we want to run when the module is executed directly. In this case, we want to run the greet function when this module called directly. So, let's add the function call here. Then, we can call this main function inside this if block. Another benefit of using this is that it lets us check whether the module is being run as a standalone program or imported into another module. When another programmer sees the if name equals main block, it signals that the file can be run as a script. If I look at a file and don't see this block, I assume it's not meant to be run directly. Instead, I think it's intended to be a library or only meant for importing. Previously, we learned the Python standard library. It's got many built-in modules that we can just import into our project. Although this library is quite comprehensive, it doesn't include everything we might need for building real-world applications. Sometimes we require features that aren't implemented in the Python standard library. That's where the Python package index comes into play. It contains many Python packages developed and maintained by the Python community. If you visit pypy.org, you'll see that there are currently nearly 600,000 projects registered in the repository. Pretty much anything you need, you can probably find on here. It's better to first check that something exists in the standard library. If not, then you can search here. Let's say you want to work with CSV files in your application. Simply search for CSV here. As you can see, currently we have over 10,000 projects for working with CSV files. But you need to remember that not all of these are useful. Some of these are bad and may be buggy or incomplete, but if you do a little bit of research, you can find a good stable package for your application. Now, let's look at how to install these packages in our Python application. So, there's several ways that we can actually install a package from PyPy. Pip is the standard package manager for Python. If you're using Python version 3.4 or above, pip should already be installed. Now, if you want to check the version of pip, let's open up the command prompt and type pip-version. If you're on Mac, similar to Python, you should use pip3. As you can see, currently the version that I'm using is 24.3.1. Now, if you need to upgrade pip, use this command, pip install -- upgrade pip. As you can see, mine is up to date. To install a new package, we can use this command, pip install and then package name. Let's install the package called requests. This package allows you to make HTTP requests to retrieve information from websites. So, you can see this is successfully installed. If you want to list all the installed packages, you can use the pip list command. Here's all of the packages that I currently have installed. Here, you can see we have installed the version 2.3 of the requests package. We called this semantic versioning. The first number represents the major version. The second number represents the minor version, and the third number represents the patches. The patch number is incremented for minor changes and bug fixes that don't change the way the package works. The minor version is also incremented for releases that add new features that are backward compatible. The major version is incremented for the changes that are not backward compatible. For example, in the request package, the major version is 2, the minor version is 32, and the patch is 3. So, you need to remember that if you use the version 2.32.33 in your project, you can upgrade it to any version that has the major version 2. If you install it with a higher major version, for example 3.0.0, your application may not work correctly. To check to see if any of your packages are outdated, type piplist -- outdated. If you need to upgrade one of your packages, type pip install the name of the package. Sometimes you may have to install a specific version of a certain package. In that case, you can specify the package version using the double equal syntax. To uninstall a package, let's say pip uninstall and then package name. In this case, it's requests. Here, we don't care about the version. And you can see we successfully uninstalled the request package. As you start working on larger projects, you'll begin installing various packages and modules, some of which may only work with specific versions of one another. Currently, the way we've installed everything allows us to use only one version of each package on the computer. With this setup, it's not possible to have multiple versions of packages installed at the same time. To solve this problem, we need to create an isolated virtual environment for each application and install the necessary dependencies within that environment. Then, we can have multiple versions of packages and modules on the same machine while allowing different projects to use different versions. There's a tool you can install called pipenv, which enables you to use pip along with a virtual environment to install packages specific to each project. So, before pipenv, we used pip to handle packages and used virtual env to handle virtual environments. But now, with pipenv, these can all be handled by one tool, and we can simply install pipenv by using pip. Let's say pip install pipenv. Now, let's say we're starting a new project so that we can see how we can install packages for that project and also create a virtual environment automatically. So, I've created a directory on my desktop called New Python Project. But you can have a project folder located anywhere. Now, let's navigate to this project using the command prompt. So, let's say cd desktop/new Python project. Right now, this is just an empty directory. Now, inside this project, let's install the requests package. Let's say pipenv install requests. So, here you can see that the location of that virtual environment. And next, it says that it created a pip file for this project. The pip file is going to be a file that describes our environment. Basically, it just tells us which packages we have installed and what version of that package we're using. Here, you can see we have another file called pipfile.lock. This file is similar to our pip file, but has some key differences. Basically, pipfile.lock is a file we're not supposed to touch. This lock file will absolutely give you the exact same environment every time, and you only get a different build when you explicitly update the lock file. the pip file could see a new version of your package and update them accordingly, and then once you're sure that all of your code is still working in development after you've updated those packages. Then you can simply update your lock file, which will give you the exact packages that are installed at the time that you know work well. And once you update that lock file, then you can push that all to production. Now, let's see how to activate our virtual environment. To activate the virtual environment, let's say pip env shell. Now, usually when you have an environment activated, it will add something to the beginning of your prompt in the command line. So, you'll notice that in parentheses, it shows new Python project, along with some letters and numbers. That's the virtual environment that it created for this project. Now let's say that we want to deactivate the environment. We can simply say exit. Now, if we want to remove any of the packages that we've installed, we can use the uninstall command. Let's uninstall the requests package. So we can just simply say pip env uninstall and then the package name, in this case, requests. And you can see we successfully uninstalled the request package. Now, let's see how to install a package using PyCharm. In PyCharm, navigate to the main menu, select the file, and then select the settings. Here, let's select Project, and then click Python Interpreter. To add a new package, let's click on the plus sign here. So, these are all the available packages that we have. In the search bar, we can search for the package we want to install. Let's search for the requests package. Now, select the request package, and all we need to do is press the Install Package button. Here, the venv folder is the virtual environment for this project. Now let's open this lib folder and then select the site package folder. This site packages directory is where the packages will be installed specifically for this project, so it doesn't affect any other projects. Here you can see our requests package. Now we can use this package just like we use modules from the Python standard library. On the top, let's say import requests. Now let's try to get a web page. For that, in this package, we have a get method. Let's call it. Let's create a new variable called response and set it to requests.get. Inside the parentheses, let's send an HTTP request to pypy.org. Now, let's print this response object. Now, let's run the program. As you can see, we got a response with the status 200. At this point, you've learned how to create a virtual environment using pip env, how to activate an environment, install a package in that environment, and how to exit from a virtual environment after using it. Lastly, we've learned how to install a package using PyCharm's virtual environment. Now, you pretty much know everything you need to about virtual environments in Python. In this section, we're going to learn how to work with files and folders in Python. File handling in Python allows you to create, read, write, and modify files. First, let's look at how to read a file. So, I have a file here called names.txt in the same directory as my Python file. Now, if I open this file, we can see that it's just a plain text file with multiple lines. So, let's see how we can open and read this file from within Python. To read a file in Python, we need to use the open function. Let's say file equals open. And we're just going to open that names.txt file. This file is within my project folder, so I only need to specify the file name. However, if the file was located somewhere else, you would need to provide the full file path. Now, we need to pass the second argument, which is the mode. This argument allows us to specify whether we want to open the file for reading, writing, appending, or both reading and writing. By default, if we don't specify any mode when opening a file, it opens the file for reading. Here, we don't need to specify the mode because we're only reading the file. Now that the file is actually open, we can proceed to print its content. We can use the read method to get the content of the file. Let's say print file.read. And also, before I run this, there's one more thing that we have to do here. If we open a file, then we need to explicitly close the file when we're done using it. And to do this, let's say file.close. Now that we've closed the file, let's go ahead and run our program. And we get the contents of the file. So, if we open the file like we did here, we need to remember to explicitly close the file. If we don't close the file, then you can end up with leaks that cause you to run over the maximum allowed file descriptors of your system, and your application could throw an error. But if we use a context manager to open files in Python, we don't need to manually close the file. It gets closed automatically once we're done with it. So, let's open this file using a context manager. Let's say with open names.txt. And then I'm going to say as file. Now, let's put this print statement within this code block. Now, we can remove these lines. If we run the program, as you can see, we get the same result. If we want, we can check if the file is closed by using the closed attribute. Let's say print file.closed. If this file is closed, this will print true. If it's still open, this will print false. As you can see, we get true, which means our file is closed. Let's say we want to read just the first few characters of the file, like the first 6 characters. To do this, we can pass the number 6 to the read method. If we run this, we should see only the first 6 characters from the file. Now, let's say we want to read the entire line. For that, we can use the readLine function. And this is going to read the first line of the file. Now, let's add another readLine function. Now, when we run the code, we get both the first and second lines. And notice, there's a space between the lines, which is different than when we were reading the entire file. This is because the print statement ends with a new line by default. But if we pass in an empty string to the end of our print statements, then it will no longer add in that extra new line. And now you can see that the lines are displayed on the console exactly as they appear in the file. When you read a file, the process moves through its contents until it reaches the end. For extremely large files, reading the entire file at once can use up a lot of memory, which is something we want to avoid. At the same time, we don't want to repeatedly read through thousands of lines manually. Instead of using the read line method, we can efficiently iterate over the lines using a for loop. This way, the file is processed one line at a time without overwhelming the system. Let's say for line in file. And then we're going to go ahead and print the line. Now, this should loop through and print each line. And you can see that it printed out all of the lines in our file. Now, this is efficient because it's not reading in all of the contents from our file all at once. Now, let's say we can't find this file. Let's assume we forget to include the file extension. As you can see, if the file is not found, we'll get a file not found error, which will crash our program. To prevent this, we can handle exceptions when they occur. Let's add a try block to manage the error and keep the program running smoothly. If an exception occurs, we can catch it by specifying the name of the exception using the except keyword. Now, let's also print a message if the file doesn't exist. Now, let's run the code one more time. As you can see, now we get this message and our program didn't crash. If the file is found, the program will proceed to read its contents as expected. And that's how you can open and read a file in Python while handling potential errors. Next, let's see how to write to a file. In this lesson, we're going to be writing files in Python. First, let's see what happens when we try to write to a file that we've opened in read mode. To write to a file, we use the write method. For example, let's write the word test to this file. So let's say file.writeTest. Let's run the program. So, as you can see, when I try to write to a file that's open in read mode, we get an error indicating that the file is not writable. So, we need to open the file in write mode in order to write to it. To do this, we just need to use a lowercase w for write mode. In write mode, if the file doesn't exist, it will create a new one. So here, I'm going to specify names2.txt. As you can see in our directory, we don't have a file named names2.txt file yet. If the file doesn't exist, Python will create it for you. But if the file already exists, it will be overwritten. So, be careful when writing to a file that already exists, because it could overwrite the current content. Now, let's change this test to a person's name. Let's say Sophia. So, after I run this code, we should have a text file within our project. Now, let's open this file. Let's add another name. Let's say Oliver. As you can see, the file now contains the name Oliver. If you don't want to overwrite a file and instead want to append to it, you can use a lowercase a for appending. So, I would like to append another name to this file. Let's say Isabella. If we run the program, you'll see both names appear in the file. However, they're on the same line because we didn't include a line break in the text. To make the second name appear on a new line, we need to add a new line character to our text. First, let's remove the name Isabella from our text file. And that's how you can write to or append a file in Python. In this lesson, we're going to learn how to copy files in Python. To copy a file in Python, you can use the shuttle module, which provides a high-level operation for copying files. So, let's import the shuttle module. With this module, there are three basic functions to copy a file. So, we have copy file, copy, and copy to. Copy file will copy the contents of a file. Copy function copies the content and the file metadata from the source to the destination. You can also use copy to, which is like copy, but also attempts to preserve all file metadata, including timestamps. In this lesson, we're going to use the copy file function to copy the contents of a file. So, let's say shuttle.copyFile. This function takes two arguments, the source file and the destination file. For the source, I'm going to use my names.txt file. Since this file is located within my project folder, I only need to specify the file name. If the file were located in a different directory, I would need to provide the full file path. For the destination, let's create a new text file called names_copy. Now, let's run the program. As you can see, we now have a file named namescopy.txt with the same content as the original names file. That's how we copy a file using the copyFile method. Next, let's see how to delete a file. To delete a file in Python, you can use the OS module. OS means operating system. This module provides a way for Python programs to interact with the operating system. So, let's import it. Now, let's delete our names, copy.txt file. So, to delete this file, we can use remove method. Let's say os.remove, and now we need to put file name here. Since this file is located within my project folder, I only need to specify the file name. Otherwise, if the file is located elsewhere, I would need to specify the full file path here. Now let's run this code. And you can see that namescopy.txt no longer there. Now let's run this code one more time. We're seeing an error because the file isn't available in this case. To avoid this error, we can check if the file exists by using the exists method. Now, let's do that. Let's say if os.path.exists. This function checks if the file exists before trying to delete it, preventing an error if the file isn't found. So, to check this, let's delete the names2 file. if the names2.txt exists, then let's say os.remove. And then we'll pass in the name of the file. If the file was deleted successfully, let's print a confirmation message. Let's say print file deleted successfully. Now, let's also add an else statement. Here, we can display a message if the file does not exist. Let's say print file does not exist. Now, let's run the code. And as you can see, names2.txt is no longer there, and we get the message, file deleted successfully. If we run the code again, it will show the message, file does not exist. In this lesson, we'll learn how to handle directories in Python. The first thing you need to do is import the OS module. First, let's see how we can get the current working directory in Python. To get the current working directory, we can use the getCwd method inside this OS module. Let's say print os.getCwd. Now, if we run the code, you'll see it prints the entire path to the console. This is the directory where the code is located. Let's look at how to create folders in Python. You can create new folders using the mkdir function, which stands for make directory. Essentially, it's used when you want to create a folder. Inside the parentheses, we have to specify the folder name. So, let's call it test. Now, if we run the code, you can see that a new folder has been created in our project directory. Next, I'll show you how to handle folders within folders, known as subdirectories. For that, we have another method called makeDirectories. This function creates directories recursively. This means it will create any necessary intermediate level directories. Let's create a new folder called test2 inside the test folder. And now, inside the parentheses, let's say test /test2. Now, let's run the code. As you can see, inside the test folder, we now have the test2 folder. Now, let's learn how do we change the directory. For that, we have a method called chdir. Let's say we want to change our current working directory to the test directory. Let's say os.chdir. Here, we need to provide the path as the argument. So, let's go to our project location. Select the test folder, hold the Shift key, right-click, and then select Copy as Path. We can then paste it here like this. If you have backslashes in your file path, you'll probably need double backslashes because that's the escape sequence for a backslash within a string. Also, we can use a /. I'll use the / because it's cleaner than using double backslashes. Now, let's print our current working directory. As you can see, this is our new current working directory. Now, let's look at how we can list the contents of a directory. First, I'm going to add a text file inside our test folder. Let's call it summary.txt. So, we can use listdir function to list files and all the subdirectories in a specific directory. Let's say print os dot listdir. These are the files and subdirectories inside our test folder. We use the rename method to rename a directory. This method takes two arguments. The first argument is the current name of the directory we want to rename, and the second argument is the new name for the directory. Let's say we want to rename test2 folder to test3. As you can see, our test2 folder has been renamed to test3. To check if a directory exists, you can use the exists function. This function checks whether a directory exists at the given path. Inside the parentheses, we need to provide the folder name. Let's check whether the test3 folder exists or not. If this folder exists, let's print this message. Let's say print folder exists. Else, let's say folder does not exist. Let's check if the test2 folder exists or not. Let's run the code one more time. As you can see, now we get the message, folder does not exist. Now, let's check if the given path is a directory. For that, we can use the isdir function. So, let's copy this code and paste it here. Now let's say os.path isdir. Here, let's change the message to it's a directory. Here, let's say it's not a directory. Now, let's check if test3 is a directory or not. Here, we need to change to test3. Now let's run this. So, we get the message, it's a directory. Now, let's change this to summary.txt. If we run this code, we get the message, it's not a directory. Finally, let's learn how to remove directory. So, we can use the rmdir method to remove the directory. I'm going to remove this test3 directory from our project. Inside this, we need to pass our directory name, test3. Now, let's run this code. As you can see, the test3 directory no longer exists in our project folder. It's important to note that this function will not delete a directory if it contains files. In this lesson, we'll learn how to work with JSON files. JSON, which stands for JavaScript Object Notation, is a widely used data format for storing and exchanging information. You'll see JSON used a lot when fetching data from online APIs. First of all, I've imported the JSON module at the top of the file. And I have an array of people info objects. Each item in this array is a dictionary, because each person object has properties like name, age, and city. So, each person object is a collection of key value pairs. Now, let's learn how to write this people info array to a JSON file, let's say with open function. Here, we need to pass our file name, peopleinfo.json. Then we specify the mode as W for write. Then, let's say as file. Now, we can use the dump function inside this code block. Let's say JSON dot dump. The dump method will convert our dictionary to a JSON string and output it. Here, we need to pass two parameters. The first parameter is the array peopleinfo, and the second parameter is file. Now, let's run the code. Here you can see we have a peopleinfo.json file. If you want, you can add indentation after each key value pair. So, here, after our second argument, we can pass in a keyword argument of indent. If we want 4 spaces for indentation, we can simply set indent equals 4. Now, let's run the code one more time. So, you can see, now it's more readable. Next, let's see how to read a JSON file. To read the file, we'll switch the mode to R. And we can remove this line completely. And let's use JSON.load. And here, we need to pass our file object. This will return an array of dictionaries. Let's create a new variable called data and assign this to it. Now, let's print this variable. Here's the first person info. Now, we have a dictionary. Using the another square brackets, we can get the value of any of these keys. So, this is all about working with JSON files in Python. A higher order function is any function that either accepts another function as an argument or returns a function as its result. This concept allows for more abstract and flexible code, enabling functions to be treated as first-class citizens in Python, meaning you can pass them around, store them in variables, or return them from other functions. First, let's look at an example of how to pass other functions as arguments. Here, I have two functions called add and subtract. Both of these functions will take numbers as their arguments. The add function will return the sum of two numbers, while the subtract function will return the difference between the two numbers. Now, I'm going to create another function called apply operation. So, this function has 3 parameters. The first one is the function. Let's call it func, short for function. Then we have 2 parameters. Let's call them x and y. Now, inside this function, let's return the result of calling func with the parameters x and y. Now, let's say result equals apply operation. Inside the parentheses, first let's pass the add function, followed by the numbers 5 and 3. Here, apply operation is higher order function because it takes another function as an argument. Now, let's print the result variable. If I run the code, we get 8 as the output. Now let's pass the subtract function as an argument. Now we get 2 as the output. In this example, the apply operation function is flexible, because it can accept any function, not just add or subtract as its argument. Instead of writing separate code for every possible operation, you can define the logic separately and pass it into apply operation as needed. You can easily swap out add for subtract or any other operation without modifying the logic inside apply operation. This reduces redundancy because you don't have to re-implement the logic for applying operations to two numbers every time. Now, let's see how to return a function as a result. Let's say we have a pair of nested functions. The outer function will be called multiplier. We will accept a number as an argument, which we will call n. And inside this function, we have an inner function called multiply by. We will refer to the argument that is passed in as x. Now, let's return the product of x and n. Now, within the outer function, we're going to return our inner function. In this example, multiplier is a higher order function because it returns a function that multiplies by a specific number. Now, to access the nested multiply by function, I first need to call the outer multiplier function and pass a number as an argument to serve as the multiplier. The multiplier function will return the multiply by function, which we can then assign to a variable. Let's create a variable called times_3 and set it equal to the result of calling multiplier, passing in 3 as an argument. Then let's print times_3 and pass 5 as an argument. Now, if we run the code, we get 15 as output. Let me explain what just happened here. Our program begins at this point. Here, n will be set to 3, and will remain that way until we finish the program or reassign a new value to n. Now we're skipping this function because we did not call it yet. We're returning multiply by and assigning it to a variable, and we can call a variable if it has a memory address of a function, which is what we're doing in this line. Now, we're calling times_3 and passing in 5. So, x equals 5 and n still equals 3. We're returning 5 multiplied by 3 and printing it. Here are some common examples of higher order functions in Python: lambda function, map function, filter function, and reduce function. Now, let's take a closer look at each one, starting with lambda functions. In this lesson, we're going to talk about lambda functions in Python. Lambda function is a simple one-line anonymous function that we can pass to other functions. The major difference between an anonymous function and ordinary function in Python is that we don't define the anonymous functions using the def keyword. The syntax for writing a lambda function is like this. So we write lambda followed by the parameters, a colon, and then the expression. A lambda function can take any number of parameters, but can only have one expression. They're useful if you need a function for only one use or a short period of time. Let's say we have a normal function named square. This function accepts one parameter named x and returns x times x. Now, let's call this function. Let's say print square, and then pass in a number 5 as an argument. If we run this program, we'll see 25 as the result because 5 times 5 equals 25. Now, let's rewrite the same function, but this time we'll use a lambda function. First, let's comment these lines. Let's say lambda. Next, we define our parameters. In this case, we have only one parameter, x. Then let's add a colon. And then our expression, x times x. Now, this lambda function will return a function object, and we can assign it to a variable like this. Now, you can see, with this syntax, we don't need to use def for defining a function, we don't need to give our function a name, and we don't need the return statement. If we run this code, we'll get the exact same result. This is how you define lambda functions in Python. Now, of course, this can work for more than one parameter as well. We can also pass multiple parameters. Instead of just x, we can say x and y. And then I could rename this to sum, for example, and then I could just return x plus y. And then here, I just say sum. And let's pass 10 and 20. If we run this program, we'll see 30 as the result. So, this is how we write lambda functions in Python. The map function in Python is used to apply a given function to all items in an iterable, such as a list, tuple, or string, and return a new iterable, typically a map object with the results. It is useful when you want to transform each item in an iterable according to a specific operation without needing to use an explicit loop. The map function accepts two arguments, function and iterable. So, this function can be a function of the core Python stack of a library or a self-defined function. Let's say we have a function named square and a list called numbers. Now, let's say we want to square all the values in the numbers list. Let's say square numbers equals. And then we just say map. And we pass the function square without calling it. So, we don't use any parentheses. And we map this function onto the collection, numbers. Now, if you want to convert this map object to an iterable, you can type cast it into a list. Now, we can print this list. If we run this program, we'll see a list of square numbers according to our number list. You can pass multiple iterables, and the function must accept as many arguments as they are iterables. Let's say we have a function called add, and two lists named numberList1 and numberList2. Now, let's say result equals map. Here, we need to pass our function add, and the two lists, numberList1 and numberList2. Now, let's convert this into a list and print the result. So, the map function can accept more than one iterable if the function expects multiple arguments. The filter function in Python is used to construct an iterator from elements of an iterable, like a list, tuple, or set, for which a function returns true. Here's the general syntax of the filter function. So, the filter function takes in a function as its first parameter and iterable as its second parameter. What it does is return only the items in your iterable that meet a user-defined criteria given by the function. Let's say that we have a list of tuples named people. Each tuple has the name of person and their age. Let's say we want to find who can vote based on their age. Let's assume the voting age requirement is 18. So let's say filter. Now, we need to pass our two arguments. As the first argument, we're going to pass a lambda function. Now, let's say data, colon, data at index 1. Now, let's say greater than or equal to 18. So, the result of this expression is a Boolean value. If it's true, this data will be returned. Now, as a second argument to the filter function, we pass our people tuple. Now, let's assign this to a variable called eligible voters. Eligible voters is a filter object. Now, if you want to convert this to an iterable, you can type cast it into a list like this. Now, let's print this. Now, we get the filtered list. As you can see, we only have two people, Bob and Charlie, because their ages are greater than or equal to 18. So, this is how we use the filter function in Python. The reduce function in Python is used to apply a rolling computation to sequential pairs of elements in a list or any iterable. It works by applying a function cumulatively to the items in an iterable, reducing them to a single value. Now, let's see an example. To use the reduce function, we need to import the functools module. So, let's say from functools, import reduce. So, let's say we have to find the factorial of 5. Here, we have the numbers, 1 to 5 within a list named numbers. Let's say product equal reduce. Now, inside the parentheses, let's say lambda x comma y colon x times y. So, the iterable will be numbers. Now, let's print the product. If we run the code, we get the result 120. So, the factorial of 5 is 120. So, the reduce function applies a given operation cumulatively to the items in a list, processing them 2 at a time. It takes the first 2 elements of the list and multiplies them, so we get 2. It then uses this result and multiplies it by the next element, resulting in 6. We repeat this process again. 6 is multiplied by 4, giving 24. Finally, 24 is multiplied by 5, resulting in 120. In this way, the reduce function iteratively combines the list elements using the specified operation until a single result is obtained. A Python decorator is a design pattern that allows you to modify or enhance the behavior of functions or methods without changing their actual code. They're extremely powerful and have a lot of different use cases. But in order for us to fully understand what decorators are, we have to talk about functions in Python. In Python, functions allow us to treat functions like any other objects. For example, we can pass functions as an argument to another function. We can return functions, and we can assign functions to variables. Let's say we have a function called greet, and it will print the word hello. And to call this function, we would type the name of the function followed by a set of parentheses. And this will print the word hello. Now what I'm actually going to do is, rather than calling greet, I'm going to print the function named greet and not put the parentheses beside it. Now, if we run this code, you can see we get the memory address of this function. Now, what this actually means is greet is an object, and since it's an object, we can actually pass it around our program. So, I'm going to create a new function called hello, and it's going to take an argument called func. And inside here, what I'm going to do is simply call whatever this function is. Now, I'm going to call the hello function, and instead of just giving a value for func, I'll pass in the greet function. Now, if we run this code, it will print hello. This works because greet is actually an object that represents the function itself. Since it's an object, we can pass it as an argument, store it in variables, and do a lot of other things with it. So, when I called hello, I'm going to pass through the object representing function greet, then I'm simply going to call that function from inside of hello, and I will get that value returned. Now, this is the basic principle of functions in Python that we need to understand decorators. Now, let's see how to create a decorator. Let's define a function called myDecorator. Our decorator function is going to have one parameter called func. Within our decorator function, we'll define an inner function of wrapper without parameters. Now, inside of this function, we're going to call the function that we receive. Next, we will return the wrapper function. And notice here that I'm not calling it, I'm just returning it. Now, let's say we have a simple function called, say, hello. And this function just prints the word hello. Now, let's call this function. To apply a decorator to this say hello function, we're going to add the @ sign followed by the name of the decorator, which in this case is myDecorator. Now, if we run this code, we get hello. As you can see, currently our decorator doesn't do anything. So here, inside the wrapper function, we can add extra functionality. We can do anything inside of this wrapper function. For example, before this function call, let's add a print statement. Let's print before the function runs. After the function call, let's say print after the function runs. Now, let's run the code. So, you can see, first we get before the function runs, then we get hello, and then lastly we get after the function runs. So, we're decorating our original function of say hello with a decorator of myDecorator, but we're not modifying the original function. Inside the decorator function, we have the inner function of the wrapper. It's essential to have this function. First, let's remove this function call. If I run this code, you'll notice that nothing gets printed. Now, Let's remove this wrapper function as well. When I run this code, you'll see that the function gets called as soon as we apply the decorator. We aren't even calling the sayHello function directly, so we only want to execute this code when we want to call this function, not whenever we apply the decorator. That's why we need that wrapper function. Now, let's say this sayHello function accepts arguments. For example, let's say we want to add a name to the output, resulting in something like, "Hello, Emma." Here, let's add a parameter called name. Now, let's change this print statement. If we run this code, you'll see that we get a type error. If you look at our wrapper function, you'll notice that when we call this function, it doesn't take any parameters. And this wrapper function doesn't have any parameters as well. Now, to fix this issue, we can use args and kwargs. So, let's put args and kwargs in the parameters of my wrapper function. And I'm going to put the same thing inside of this function here. Now, the reason for this is that we know that this wrapper function will have a certain amount of argument. We don't know if there will be any keyword arguments or positional arguments. All we know is that there will be some kind of arguments. That's why we use both args and kwargs. The same thing goes with this function as well. Now, this will actually allow us to have any amount of arguments on any specific decorated function. So, let's run the code one more time. As you can see, now there's no issue with it. We can add more than one decorator. So, let's create another decorator. Let's call it another decorator. Now, let's add the wrapper function. Inside this function, I will print a dashed line. And then call the function. After that, I will print this line again. And then we need to return the wrapper function. Now let's apply this new decorator to our original function. Now, if we run this code, we have the following output. In this lesson, we'll learn about iterables and iterators in Python. What are iterables? Basically, anything that you can loop over in Python is called an iterable. For example, a list is an iterable because we can loop over a list. Now, lists aren't the only things that we can loop over. We can loop over tuples, dictionaries, strings, and many other types of objects. So, how can we tell if something is iterable? If something is iterable, then it needs to have a special method called double_iter. We also call these double underscore methods dunder methods or magic methods. Let's create a list and check if it has this special method. So, I'm going to create a simple list with a few items. I'll say numbers is equal to. And we'll just set this equal to 1, 2, 3. Now, I will use the dir function, which returns all the methods and attributes of an object. Let's say print dir and pass in our list of numbers. Now, let's run this code. And here, among all these methods, you can see the dunderIter method. So basically, something can be looped over if it has that method. Now, let's call this method on this numbers list to see what it does. So, here I'll say value equals numbers.iter. Now, let's print the value. if we run this code, you can see that we got a list iterator object and the memory location of that object. So, what is an iterator? An iterator in Python is simply an object that can return data one at a time while iterating over it. For an object to be an iterator, it must implement two methods, iter and next. These are collectively called the iterator protocol. In this print statement, let's say dir value. So, we can see that we have the dunder iter method here, and it also has the dunder next method as well. Now, you might think it's a little weird that this iterator has a dunder iter method because that's what we ran on our list in order to get the iterator that we have now. But it has to have a dunder iter method because iterators are also iterable. The difference is that this double underscore iter method returns the same object, so it just returns self. Now, we'll take a closer look at the next method in detail. So, we can get each element of this iterator by using the next method. The next method returns the next value in the iteration. So, let's print value.dunderNext. When I run this code, then the first element of this list is printed, which is number 1. You can see this bit ugly to run our dunder methods directly like this. By the way, instead of calling these special methods with underscores, Python has another way. So, here we can change to iter numbers like this. Inside the print statement, we can say next value. When I run this code, we get the same output as before, but the code looks much cleaner now. Now, one thing that's important to note about iterators is that they keep track of their state when you use the next dunder method. So, if we run next on this again, then it should remember where it left off and print the next value. So, I'm going to copy and paste this a couple of times. Now, let's run this code one more time. You can see that each time we printed the next value, it remembered where it left off, and the next method pointed to the next value in the iterator. So, it's never going to restart from the beginning. Right now, we've printed all of the items in our number list. Now, let's see what happens if we further try to get the next value. Let's copy and paste this print statement one more time. If we run this, you'll see that we got an error. So, if we run out of values, then it raises a stop iteration exception. When we hit a stop iteration exception, it means that the iterator has been exhausted and has no more values. So, we can see it when we run through them manually like this. For loops internally, rely on this. When you use a for loop, it internally calls the iter function on the iterable and uses the next method to get each item until the stop iteration is raised. However, when the for loop gets a stop iteration exception, it handles it gracefully and doesn't show the error to us. Under the hood, for loops use a while loop to iterate through sequences. So, basically, it looks something like this. First, let's remove all of these print statements. So, let's say while true. And then inside here, let's say try. Now, to get the next item, let's say item equals next value. And then print this item. Now, we also need to check for an exception. So, let's say except stop iteration. And if we get a stop iteration, then we will simply break out of the while loop. This is exactly how for loops work behind the scenes. A for loop internally creates an iterator object and iterates over it, calling the next method until a stop iteration exception is encountered. Now, let's see the benefits of using iterators in Python. Iterators do not load all the items into memory at once. Instead, they generate items one by one, only when requested. This is particularly useful when working with large collections or streams of data. Iterators can represent infinite sequences because they generate elements on demand. This means you can create an iterator that never runs out of elements unless explicitly stopped, such as with the stop iteration exception or a break in a loop. You can build your own iteration logic using custom classes that implement the iter and next. This provides flexibility in how items are fetched, ordered, or even filtered. In this lesson, we're going to learn generators in Python. Generators are a special type of iterator that allow you to iterate over a sequence of values lazily, meaning they produce values one at a time and only when requested. This makes them memory efficient for large data sets since they don't store the entire sequence in memory at once, unlike lists or other sequences. Generators are created in two main ways: using a generator function with yield and using a generator expression. First, let's look at how to create generator functions with the yield keyword. Here, we have a normal function called square numbers. This function generates a list of square numbers starting from 1 up to the number that we provided. If I run this code, you'll see that we get 1, 4, 9, 16, and 25. So, this function returns a list of square numbers all at once. So, we're keeping this entire list in memory. Now, let's see how we can convert this normal function into a generator function. Here, I don't need this list anymore because I'm not going to store any of this in memory. So, we can also remove the return statement. Here, we can rewrite this statement using the yield keyword. In Python, any kind of code that you create that contains the yield keyword is considered a generator. If we run this code, you'll notice that we no longer receive the list when we print squares. Here, we are getting the generator object. The reason for this is because generators do not store the entire result in memory. The yield statement returns values one at a time. The yield statement pauses the function, waiting for us to request the next result. Now, if I print next squares, it will ask for the next value and continue the function. You can see that we're getting number 1, which is the first square. Now, if we copy and paste this print statement a few times and run this, then you can see that each time that we run next, it gives the next value that's yielded. So, 25 is the last value from our result. What happens if I copy and paste this print statement one more time? You can see that I got a stop iteration exception. This means the generator has been fully exhausted. And stop iteration simply indicates that there are no more values left to yield. Now, instead of getting these values one at a time, we still can use a for loop on these generators. Now, let's say for square inch squares. And then let's print square. Now, let's run this. And you can see that we get all of our values and we don't get the stop iteration exception because the for loop knows when to stop before that happens. Now, let's see how to write this using a generator expression. So, generator expressions provide a concise way to create generators similar to list comprehensions, but with parentheses instead of square brackets. Here, let's say squares equals and then parentheses. Inside the parentheses, let's say x multiply by x for in range 1 to 6. Now, if I run this, you can see that I still get the same result. So, what if you wanted to actually print out all of the values from the generator? Like I said, they're not currently all held in memory, but you can convert them to a list. So, let's say print list squares. When you convert a generator into a list, you lose the performance benefits that the generator provided. So, you can use generate when you know you don't need to use all that information at the exact time. You can save some resources and optimize your program. But in general, for small programs, there shouldn't really be any reason to use the yield. In this lesson, you'll learn how to connect to an API using Python. First, let's see what an API is. API stands for Application Programming Interface. An API is like a waiter in a restaurant. Just as you tell the waiter what food you want, you tell the API what information you need from another program or service. The API then communicates with the server or program and brings back the data or response for you. So, an API allows two programs to talk to each other and share information, like ordering and receiving food from a menu. In this example, we're going to connect to the popular weather API called WeatherStack. It provides weather information for cities around the world. So, we can get information about the temperature, the humidity, and more. To use this API, first, we need to create an account. Without an account, we cannot get an API key, and without an API key, we cannot authorize a request. So, let's click the sign up button and create an account. I've already created my account, and now I'm going to log into the website using it. I've set up a new project called Python Weather API. In this project, we currently have only one file, which is app.py. To get data from an API in Python, you typically use the request library. So, let's install this library. First, open the terminal. Then, to download the request package, we'll type pip install requests. Now, we have that package of requests within our project folder. We use this package to send HTTP requests. To use this module, we need to import it at the top of the file like this. So, next we're going to need a way to connect to the Weather API. For that, let's create a new variable called response and set it to the requests object. This requests object has a method called get for sending an HTTP GET request to a specified endpoint. We can get the data using this method. Inside the get method, we need to pass the URL or the address of an endpoint. For that, we need to first know the base URL of the API. Let's create a new variable called base URL to store it. Now, let's head over to WeatherStack and check out their quick start guide to find the base URL. You can see, here we have the base URL. Let's copy this and then paste it here. Now, let's go to the WeatherStack documentation one more time. Here you can see that to access the current weather endpoint, we need to combine the word current with the base URL. For that, let's create another variable. Let's call it URL. This will be an F string. First, let's add the base URL and then /current. we now need to pass parameters. If we go to the weather stack documentation, we can find the current weather endpoint. Here, you can see there are two required parameters to get the current location weather details. One is access key, other is query. Now, using this query parameter, we can pass a single location or multiple semicolon-separated location identifiers to the API. Here, I'll create a dictionary called queryString to store these parameters. In order to get the access key, let's go to the quick start page one more time. As you can see, here's the API access key. Let's copy this key. Now, inside the queryString dictionary, let's add an entry where the key is access key and the copied value as its value. Let's suppose we want current weather in London City. So, set the query as the key and the London as the value. Inside the get method, let's first pass the variable URL, followed by the keyword argument params. Now, we can set the params to queryString. Now, let's print this response variable. If we run this program, as you can see, we get response code 200. This is an HTTP status code. 200 means the response is OK. Now, to get the data from this response object, we can use the JSON method. And this will convert the result into a dictionary. Because the response of this API is a JSON object, which is equivalent to a Python dictionary. So, we can store that in a variable. Let's call it current weather data. Now, let's print this variable. So, here's the weather data for London City. If we just want London's current temperature, we can access it like this. So, I'm going to use fstring. Now, if we run this code, you can see we only get temperature. If we want the weather descriptions too, we can access them like this. This is a simple example of how to get the data from an API using Python.